Good morning, everybody, and welcome to our Maths Masterclass lesson. As you guys can all see, this is being dealt with by the Cape Town Science Centre and is fueled by Astron Energy. But before we jump into today's topic, I have to first make sure, I hope everyone is still doing okay, because I know you're in the thick of things right now. You're busy with the exams, and I know you wrote Maths Paper 1 yesterday. I really hope that the lesson that the Science Center have done, which was done by Philip earlier in the week on Wednesday, I really hope that help you all in order to write yesterday's paper. Now, my name is Umar. I'm going to be helping you out with this lesson, and this one is going to be Maths Paper 2. And hopefully this is going to help you with your Paper 2 coming up on Monday. Now, a lot of you are already used to the rules by now, but I still have to say it. As you can see, we disabled all your mics as well as your videos, because while I'm presenting, I do not want to see a surprise video appear or someone busy speaking and things in the background. Otherwise, it might distract myself or it might distract everyone else that is watching this lesson. Another thing is, if you would like to get my attention, you are more than welcome to raise your hand using that emoticon, or you can just type your questions in the chat. Then either myself or my co-host Philip will be answering the questions within the chat. Another thing also, please make sure that everyone keeps focusing on the lesson itself and do not go on any tangents, which we will get to in this lesson. Do not go on any other tangents during the lesson. Also, another thing, you will see that this video is being recorded. Once this lesson is done, we will try to get this recording to you later today so that you can use it in order to study for Monday's paper. And now, without any further ado, I think I am going to start. Now, when it comes to Maths Paper 2, let me just make sure this is working. Let me take this right. Okay, and moving. Okay, so when it comes to Maths Paper 2, the first question, or at least question 1 and question 2, is all about statistics. And then it goes to analytical geometry, and we know it gets more difficult and difficult as it goes along. So we start off nice and easy, and then we're going to get to the more difficult topics. This question paper is the Eastern Cape, June 2020. So the one taken off this year. Now, you probably thought I was going to take the Western Cape paper that we have done now in this mock exams that just passed. But the reason why I changed it up is because I want this video to work hand in hand with the other paper 2 lesson that I've done earlier. Both of it was in June, but this Eastern Cape paper asked all of these topics in a different way to what the June paper that I've covered as well. So you can use both of those lessons in order to help you with your exams. Another thing is, when it comes to this paper, and we're going to be working through all of it, I really hope it out as well, because during the lesson, we will be asking you to give your answers as well. And then we won't wait for that entire amount. I'll just wait a small bit, see if the answer is correct, and then we'll carry on. Now, as we can all see over here, this question is going to be 1.1, where it states, let me just get my paper out so I can read. The maximum daily temperatures in Bloemfontein for the first 11 days in January were recorded as indicated in the table below, which is given over here. Then all the values are there. 1.1. Calculate the mean for the maximum daily temperatures for the first 11 days in January. So the first thing we are going to do is we need to arrange this in ascending order. So in the meantime, if you know, if you have the that type that answers in the chat, make sure I have the chat open. And then let me show you how we're going to answer this question. So let me get my pen out. So the first thing we are going to do is we are going to arrange this in ascending order. So let's see. We start with the lowest value. So it is 17. So let's take 17 away. We have 17 over here. Our next value will be 26. We'll take 26 away. 26. Right. Next, we're going to look at the next one would be 27. Here's a 27 over here. The next one, there's another 27. So we write that down. Okay. Next is 30. So we'll write that down. Then we'll go look at 32. Looks like it's next. Then we have 34. Then we have 35. Let's see what's next. So I only have a few left. So this is going to be 36. Then we have 37. And finally, we are left with 40. So now we have arranged all of these in ascending order. So now using this, we will go through all our other topics. Now, I'm going to try and get this lesson done within an hour. But from what we've seen in the previous lesson when we ran the June exams, we went in quite a lot of detail and I showed you how to calculate these things on your calculator. So if you watch that video, you're more than welcome to see how it is. But I won't be able to bring up the calculator right now, but I will explain to you how we are going to answer this. Now, you might be using different calculators. Personally, I use a Casio calculator. And in order to get the mean, okay, I see here someone saying they can't see the screen. Please just make sure that if you cannot see the screen, and if maybe other people can't see the screen as well, maybe just leave the meeting and come back in, and then you'll be able to see it, right? Make sure you try and calculate these values as well. So by all means, you can try and calculate the mean. Now, if you're going to use a calculator, you are going to type in, you're going to place it in stat mode. And then all you have to do is you're going to have to go to mode, then option 2. And because all of these are a single variable data, because you see we don't have another row of data that we have, we will then select option 1. So once again, you put in stat mode, then you're going to select option 2. And because dealing with single variables, it's going to be option 1. Once we have it like that, you'll place it into the table format that shows up. Now, in this case, you're going to then type in your 17, and then you press equal to. And then you type in your next value, 26, and you go on every time like this. Whenever you place in a new number, you're going to press equal to. Once you have all your values that you have, you are going to press clear on your calculator. Then once that is done, you are going to press the shift button and then the button 1 in order to go to stat mode. Once you are there, you are going to choose option 4. And the reason why we're going to choose option 4 is because once again, this is a single data variable that you have. You type all of that in, and then because we are now going to look for the mean in this case. Because remember, you're more than welcome to add it up and check your mean over there. But we want to get all of this and make sure we are correct. So you're going to look for the mean. And in my case, I just had to press option 2 on my calculator. And eventually, when you do all of that, you'll see that your answer for mean is x bar is equal to 31. And that's how you're going to get this answer. So there you see it's just worth 2 marks. First thing you do is arrange in ascending order, place it into your calculator, and then you're going to just check out whatever they ask you. Now, that was for option for 1.1. Now we're going to move to 1.2. We have to calculate the standard deviation for these values. Now, because I already wrote the increasing values on the previous page, this is just what was in the question. Now, because you already would have placed all of these values into your calculator, in order to get the standard deviation, all you will then have to do is, once again, let's say Casio calculator that I've used, and then you're going to press the button 1 on your calculator, which will then take you to stat. Now, because you want to deal with standard deviation, you're going to select option 3. If you're using other calculator, it might be another one, but like I said, I've used this one. So then you're going to select option 3. And then it will give you your standard deviation. And your standard deviation, in this particular case, is going to be, as our x value is going to be 6.19. And that's where you're going to get this answer. So you just follow those steps. This is how you will get it. Now, moving on. How many days were the temperatures more than one standard deviation of the mean? So, okay, what we need to do here is, okay, we're looking at the mean and standard deviation, but more than one of the standard deviation. So what's going to happen is we're going to take the mean that we have, so it's that x bar, plus one of our standard deviation that we have over here. We're going to have it like this. So what was our mean? Well, it was 31. If you look over here, it's 31. And our standard deviation is 6.19. So we're going to type that over here or write it out. That's going to be our 31 plus, so it's our 1 times our standard deviation, which was 6.19. We are going to type that in our calculator, and then you'll see, you'll get the answer of 37.19. Now, with these values, you need to now see which of these, out of the days that was in our data sets that we had, which ones are higher than this value? Well, if you look, it's higher than this value. If we look at what we have, the only value that's higher is 40. So that means how many days were the temperatures more than 1 standard deviation? There's going to be 1 day. And that's going to be where you get your 3 marks. All right. Does everyone understand how I got these so far? Remember, you can type it in the chat. You can say if I'm going too fast or too slow. Yes, you can write your questions in the chat if you have a question. Yeah, remember, just type your questions in the chat. All right, and then I'll try and get to it. So, okay, that is going to be how we done our 1.3. Now, we'll move on to our next ones, and our next one is going to be for 1.4. So, here we need to determine the interquartile range of the data. So the first thing is we need to make sure that we have it in our ascending order. So just as a recap, a 17, 26, 27, that is 27 again, 30, 32, 34, 35, there was a 36. Let's make it a bit better so everyone can see. A 36. There is a 37. And finally, a 40. So out of all of these that we have here, in order to determine the interquartile range, what you need to do is you first need to see how many data sets do you have over here. Okay. So we're going to see. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So we have 11 numbers in this data set. Now, the first thing we are going to need to do is we are going to need to find the median. And that is the middleest most number out of your data sets that we have. Basically, the ones that's going to split your data set into 2 equal parts. And if we look at that, it is going to be our number 32. Because now, on the left-hand side, here we see we have 1, 2, 3, 4, and 5. And then on the right-hand side, 1, 2, 3, 4, and 5. So now we know, okay, we split it nicely in the middle. We had our number 32 and split it 5, 5 on either side. Now, in order for us to do this interquartile range that we have, we are going to do this 32. And we're going to find the halfway that's there as well. So the halfway that's going to be there is going to be this one. That is going to be our Q1. Right, this will be our Q2. Then, because this is Q1, you'll see it's because this is 1 and 2, and this split up as 1 and 2. Now do the same on this side. Is going to be our 36, making this our Q3. So we'll have it like that. Right, so it's going to look like this. So we have our 27 as Q1, we have a 32 as Q2, and we have our 36 as Q3. Now, what we're going to do is we need to calculate the interquartile range of the data set. All right? And that is going to be with the formula, or at least I'll just say it's IQR, which is our interquartile range, is going to be our Q3 minus our Q1. Our Q3 in this case is 36 minus our Q1, which is 27, and that's going to give you a value of 9. And as I've seen over there, a few of you have answered already. Thank you. And your final answer over there is going to be 9. And that is another quick 3 easy marks, right? Just like that. So see, statistics is a very nice topic to go over, and it's a nice way, an easy way to get some marks. Okay, now we move on. So we move on to 1.5. Here we need to draw a box and whisker diagram in the grid provided in the answer book. All right, so you'll get the answer book over there. I'm just going to draw it out over here. Now, the first thing you do is when you have a box and whisker plot, always draw a number line. All right, so you have your number line over there. The lowest value I have is 17, and the highest is 40. Now, if I'm going to count now, 17, 18, 19, 20, 21, 22, 23, 24, it's going to take a very long time, and the spacing is not going to be, I don't think I'll have enough spacing. So I'm going to make it by 2 every time. So I'll start with 17, 19, 21, 23, 25, 27, 29, 31, 33, 35, 37, 39, 41. And there is our number line that we have over here. Now, what was our minimum value? Well, it was 17. So we'll put a dot over there. That's our minimum value. I'll just put min over there. Then our maximum was 40. So that is in line over here. That's where we had our 40. So that's over here. We have our 40 max. Right? And then we are going to place our 3 Qs that we had. We said in the previous one, so here everyone can see, Q1, 27, Q2, 32, and Q3, 36. So here we go. Q1, 27, Q2 was 32, and Q3 was 36. And then you just find this on your number line that you have created. So that's going to be 27, Q1, which is this one over here. We'll make a nice line. Q2 would be 32, so that's over here. Another line. And Q3 is 36, would be here. Another line. And then the box and the whisker. So now you're going to join your Qs together. So this is going to go all the way around. You join it to your last Q. And then you move it all the way this way. You make this like that. So this was our Q1, our Q2, and our Q3. And then we are not done. That's our box. And now we do our whiskers. So just the lines from the side of your box to your max and the side of your box to your min. And that is where you get 3 marks. Nice and easy. Right? And this is just how we dealt with our 1.5. And that was question 1 done. Just like that. And this was a total of 12 marks. Right, so question 1, just 12 marks. Is give or take about 12 to 15 marks within your paper. Remember, when it comes to your exams and you're doing this, just make sure that it's about a minute a mark. that you will have to make sure that you are carrying on with this paper. So, okay, now in question 2, here it says, in a certain school, the analysis of mathematics matric results in percentages were represented in the cumulative frequency graph, which is an ogive, given below. And as this over here, questions. 2.1. Complete the frequency table provided in the answer book. All right, so I don't have an answer book. I have these slides over here, and this is how we're going to be dealing with this. So this is how it's going to work. The first part that we're going to do is, and the reason why I chose this one is because in the other exam paper, we literally had to calculate the cumulative frequency and then get our marks. Now you see we had to calculate the frequency and then move on. So see us working hand in hand with each other. So, okay. Okay, here we go. Now, the cumulative frequency of our first line is just going to be this number over here. So that's going to be our 4. Right? So we're going to have our 4. Then next, we need to find out now, okay, what's we going to get for our next line. So then all we have to do is we're going to have to say the main number that we have here is going to be our 18, and we're going to minus it from our 4. That's going to be 18 minus 4, and that's going to be equal to 14. So we'll write 14 over there. Then next, we're going to take our next value, which is 36. And now you're going to minus that from the number above. So every time I'm just going to do that. So now it's going to be 36 minus 18. And that's going to give you a value of 18 as well. So you're going to put 18 over here. Now we're going to carry on with that trend. It's going to be 50 minus 36. So 50 minus 36 is going to be equal to 14. Let's just erase that. It's going to be 14. We place that over here, 14. And then it is going to be our last one, which is going to be our 54 minus 50, which is just going to be 4. But just to show everyone, 54 minus 50 is, of course, equal to just 4. So place our value as 4. And that's how we completed the frequency table in this answer book. And that is, all of that is going to be worth 2 marks. Right? And that's how we got this. Now, 2.2. Use the above graph, or in this case, it's on the left-hand side. We need to use this in order to answer the following questions. Here it is, 2.2. Write down the total number of matriculants who wrote mathematics in this school. So you can use the graph that we have, or we can just use the table that was just given to us. Each line on here is worth 1, so you'll be able to count it like that, and then you will be able to see what number is over there. Or what you could actually just do is you go back, you go look at your cumulative frequency table, and this amount here in the bottom right-hand corner is the total amount of learners that have written this paper. And thank you once again. I see people is answering in the chat, which is very good. And that is going to be 54, because that is the total for our cumulative frequency that we got. Now, 2.3. Here we need to write down the modal class. Now, the modal class is basically the line that we have, or the frequency with the most percentage that we have. So what I'm going to do is I'm going to let you try and answer this, and I'm going to put it on the slide where you can see this over here. This off the slide, because we're not going to need that. And now in the chat, I want the people to state what is the modal class of these values that we have over here. I can take all of this away as well, and this. So the only thing you're going to need is this. Okay, I see the answers coming nicely in the chat. That's good. Okay, yes. Yes, you got it. So in order to do the modal class, you go look at your frequency and you look at the number which is the highest frequency that we have, and that is 18. And 18 is not the answer, as you guys have all put in the chat, which I'm really glad about. And that is going to be this value over here. So it's going to be that class that you'll have. So you will write it out as, so let's go write it by the correct place, which is this over here. You're going to write it as your 40 in line with x to 60. And that's where you'll get that 1 mark, right? And that's correct. This is 40, and x is greater or equal to 40, but less than 60. Please do not put another line under there. That's not true because 60 is included in the following data set. I see someone saying that they can't see the board. Can anyone else see the board? That's just there's 2 people. Like I said, okay, I see there's other people are saying they can. Okay, so please just exit the meeting and come back in. We'll allow you back in. Don't worry, we won't keep you out of the meeting. Please. Okay. Okay, there's quite a lot of you actually, so maybe it might be my side. Let me just stop sharing just in case. Going to share again. There we go. Everyone should be able. Yes, Mako is saying that you can see. So now just hope that everyone else can see as well. Okay, now let me just get the chat back. Okay, can everyone see now? You can just give a thumbs up in the chat. It's visible. Okay. Yeah, anonymous. The reason I'm saying no is because, and thank you for the confirmation, everyone else. We're not going to draw the box and whisker blot on top of the number line. That is mainly for us to see where numbers are, and that is, oh, if you mean on top, you mean above, right? So yes, it should be above the number line like that, but it shouldn't be on the number line itself, right? That's just for your reference purposes of where you're going to place these values. So, okay. Now, let's move on to the next question. So see, these are nice, quick and easy marks so far. 2.4. Estimate the median percentage for mathematics of this school. So, okay, if they say the median percentage, remember median is halfway. So what do they want? Half percentage. And what is the half percentage usually? Well, we know whenever we deal with percentages, it's always out of 100. So the median percentage is going to be 50% for us to focus on. Right. So here they want to know what is the median percentage of mathematics in this school. So as you can all see over here, we saw the total amount of learners that write maths in this school is 54. If you do not believe me, remember, this is where we got it. So what this actually means is we need to get 50% of that 54 amount of students. Now, the way we're going to deal with that is when it comes to 50%, we're going to change the decimal. So 50 divided by 100, that's going to give you 0.5. So we are going to use 0.5 of our 54 learners. So the way we're going to deal with that is we will say it is 0.5 of 54. And you will then say 0.5 multiplied by 54. And if you're going to type that in your calculator, you'll see it is equal to 27. Now, that is not the final answer that you're going to have for this. Right? This is 27 that you have. What you will then have to do is you will then go to your percentage obtained. Right? So you could also see the percentage that you have, which is this part up here. You are going to go and look for 50. So 50 is going to be the halfway mark over here. each line is 1, so that means it's going to be 1, 2, 3, 4, 5, 6, 7. That line. You then go and you make a dot over there. And that's the values that you're going to have. So you will have exactly. So at 27, we want to see, we make sure. So we are going to take this 27. You start counting upwards until you get to your 27th one. You go across. And then where the two meet is this one over here. And if we move back down, it's actually perfectly on 50. So our final answer here is that we will have 50%. The estimated median percentage here is 50. So even though we began with median, that's not the same 50 I was speaking of at the start. And this 50 is that we get on the graph, which is this over here. So what we done was we took the median percentage, which was 50 divided by 100. We done it with the total amount of learners, which was 54. And then that showed 27 learners will be getting that amount. Then we went to our graph, we went upwards, we counted till 27. You move across, you get to your percentage, and then you see what the percentage is. And in this particular case, it just happens to be 50 as well. And that is where you get your 2 marks. If you understand, all good so far? Another 2 marks, there we go. Okay, now moving on. 2.5. Here it says, use the above graph on my side as the one on the left-hand side to answer the following questions. If the requirement for a learner to be admitted in a certain institution is 70% and more in mathematics, determine how many matriculants will qualify for admission. You guys are probably doing this as well now and aiming towards going to a maybe higher education as well. And you know that there's certain percentages that certain universities require. Now, this is a very similar topic, a very similar question, one that you can relate to. So in this one, we need to now see how much will get more than 70 out of these 54 learners. So can you guys please place your answers in the chat, and then we will go through the answers as well. All right, so I won't give you the full two minutes. I'm just going to try and make sure that you guys have done this test as well, and that you're trying it out as well. All right, and that you're nice and engaging. Okay, so I see someone saying that amount. Okay, we'll see. Okay, also coming in. Nice, thank you. Okay, there's quite a wide variety over here, right? So it's 10, 12, 11, 9, 10. Okay, there's quite a bit over here. So what we're going to do here is we are going to now working our way from the other way around now. Where in the previous question, we first looked at our cumulative frequency. We saw where it met on the graph, and then we went to go check the percentage. This time, they are giving us a percentage. And then we want to see the amount of learners that actually gets to this over here. So we need to now go look at where we get 70%. So our 70 going to be halfway between these two. So it's this part over here, this line over here. We're going to work our way up. It's going to be here. All right, so 70 is nicely there. And then what you're going to do is you're going to work your way to the left. All right, so it's going to be working our way to our left. All right, just where those two are. So we're going to see where we'll get the 70. You're going to work your way down and come back this side. And what you'll actually see is that amount is going to be 48. So you can even come check over here. Here we have this over here. These are the amount of learners that we have. That's the frequency of the percentage that was gained. We are going to look at the total amount of learners, which is 54. In this case, we will see that there are 14, and there was also 4 over here, right? So the frequency that this usually happened in was 14, and that was just 28, right? But what we're going to do is we're going to go back down now. And we're going to see where these two line up. So where these two meet, it will give you a value of 48. So you're going to take your total learners. I know it's a bit difficult to see on the screen right now, but what you can do is, like, when you have a nice big screen of this, you'll be able to get it as well. So total learners is going to be minus learners that got over 70%. So based on that, we'll go see. So that is going to be 54 minus our 48. And then we type that in a calculator, and you'll get the answer of 6 learners. And that's your 2 marks. Okay, yes, now I see where you guys are coming from, but just like now on the screen, it's quite short right now, so it looks like the value is a bit lower, but the value is actually 48, right? If you line that, if you make your ruler lines over here, and that's where you get it, right? But just as long as your 2 lines line up, wherever it meets up, you will then take that total amount, you minus it from the one on the left-hand side, and then you are going to get your total amount of learners. And that is where you get your 2 marks for this question. Now that was statistics. Yes. Okay, I see someone is saying that. Yes, I'll give you ranges of those answers. Yeah. So remember, you have to just make sure that you lined up correctly. Right now, because the screen was so short, I can't actually see it like that. But when I write it on my actual worksheets that I have over here, it was 48. And then that's where you just take your total minus that. Okay. Now, moving on to question 3. Now, when it comes to question 3, this is going to be your analytical geometry, right? So for analytical geometry, here it states, in the diagram below, A with points -2 and P, it has B with -4 and 0, C with -1 and X, and -3, and D with 4 and -1, are the vertices of a trapezium. AD is parallel to BC. Point G is the y-intercept of line AD. F lies on the line AD. So all of this is given over there. Now they say we need to determine the length of BC. Whenever they say determine the length of BC, we know we have a distance formula that we can make, but I always like writing out my values first that I'm going to use, or at least in this case, everything's on the slide, so I can just focus on that. Or let's show you how I would answer it. I would write it B, which is -4 and 0, and our other value that we're comparing it to is C, which was -1 and -3. And just like this, right? Then we say, okay, this is our X value of B. This is our X value of C, our Y value of C, just to make it easier to work with. So what is the distance formula we're going to be using, or at least for which line? It's going to be for line BC. So BC is equal to your big square root that you have over here. And now in this case, it's going to be the X of your first point, so it's X of B, minus the X of your other value, which is going to be X of C. Then all of that is squared, plus, now it goes to your Y values. So we started by B minus the Y value of C, also squared. That is our square root where it ends. Now we type in our values. What is the X values of B? Well, it's -4. Do not forget your square root. Have that over there. So that is -4 minus the X value of our C is -1. So they place it in this extra bracket, so we know it's different. Plus our y value of b is 0, minus the y value of our c is -3. We put that as squared. So what that basically means is that is going to give us, we can have it a long one like that. Just to show you, if we actually do the square root sections, that is going to be -4. Negative times a negative is positive. So that's actually +1 squared. And this is all going to be in the same brackets plus our 0. And this is going to be +3 squared. And then we are going to now place all of these together. So that means this is eventually going to give you square root 18. Now, that's not the last part that we're going to do. We're going to make it into its most simplest third form. In this particular case, we know that 2 times 9 is 18. And we also know the square root of 9 is 3. So you could then write it as 3 the square root of 2. And then because this is a distance formula, say yes, units. There we go. And that is the reason why. Okay, I see there's more people saying that they can't see my board. The thing is, a few other people that's here, they're saying that they can see it as well. Please just remember, go out and come back in. I have taken the screen away and then went away as well, right? Oh, and I see someone also answered the question of there. 3 square root 2. Perfect, right? And that is 3.1. And that is worth 2 marks. So far, so good, right? They tell you immediately, determine the length. You think about your distance formula. They tell you which lines as well. They've given you the points already. And bam, all you have to do is plug in, substitute, get your answer. Now, 3.2. Determine the gradient of BC. So, okay, now we need to use a different formula. Well, the gradient is going to be, we normally denote that by m of BC, right? Okay, I'm seeing answers, right? Yeah, I'm seeing someone has gave already an answer over there. Yes, yeah, let's say, do we not round off to 2 decimal places? No, we're going to leave it in the simplest third form, right? Just leave it like that, right? Just to make sure we get the actual amount, right? You don't want to round off to different numbers or anything. Just leave it in nice third form. It's okay. Okay, I see people getting it. Perfect. So now this formula is different to our distance formula. So in this case, you begin with the y values. We know it's normally y2 minus y1. But in this case, we are dealing with our b and c. So instead of saying y2 minus y1, I'm just going to say the y of my b minus the y of my c all over the x of my b minus the x of my c. And then we plug in our values. So remember, this is where you get your x, this is y, x, and y. So that's going to be the y of my b, so 0, minus the y of my c is going to be -3. Now, in this case, there are no square roots or anything. Now I'm going to the x of my b, which is -4, minus the x of my c, which is -1. We're going to type all of that in the calculator. Here you can see immediately, and this is actually going to give you +3, right? This is +3, and this is going to give you -3, right? -3. And when you, and just as a reminder, when you have a positive divided by, so positive divided by a negative, no, of course, by now we know it's always going to be a negative. So in this particular case, we have +3 divided by -3. So final answer is going to be -1, as you have all stated in the chat. So that is what our gradient of BC is going to be equal to. Great job. All good so far. Nice. Remember, if you have any questions, just place it in the chat. All right, it'll be easier to follow along over there. So I'm just going to the chat quickly. Yes. Yes, so like I said, yes, we're going to do that in third form. That's all good. Okay. So, okay, up to date with the chats. Okay, now we move on. Next question. Yes, now we move on to, yes, 3.3. Determine the equation of line AD in the form y is equal to mx plus c. Now we know when it's mx plus c, we know it is a straight line graph that we have. So we're going to deal with this over here. So let's see answers in the chat, and then I'll go through the answer as well as to how to get there, right? Okay, perfect. Let's see. Yes, 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 yes. No, this is great. This is great. This is great. You guys really know exactly what to do. I'm really glad you guys are going through the questions as well as trying to answer it as well and giving the correct answers. I hope that no one is like just sitting there with a memo and trying to do all of this. Remember, this is nice and engaging, and we will see how we get to the answers. So in this case, what we will see here is, right, this is 3.3. We see that line AD, which is this one over here, AD, so the one that goes all the way down here, AD, right, is parallel to BC, which is this one over here. Right, we have that too. So that means if we have the gradient of these two, so the gradient of BC would be equal to the gradient of AD because they equal to each other, right? Both of it is like this. It's the correct gradient, the same gradient as goes up this way and that way over there. Now, yes, that's correct. And so if we're going to use the value of C, we'll just substitute these values into D, right? Of that's what we have over here, right? Just to get the correct values because you know what A is, and I'll just get the part of D's. So here we see, want to use, determine the equation of line AD. So D we know is going to be 4 and -1, which is the spot over here. Okay, now we're just going to plug that into the formula that we have over here. So we are going to say this y is equal to, now we know the gradient because we just calculated in the previous one. We see the gradient was -1. So that's y is equal to -1 x plus c. So that's our initial value. We choose a point on our graph that we have over here, in this particular case, in this line that we have, which is AD. We're going to choose that point. So this is our x value. This is our y value. So now we type that in. So that is going to be -1 is equal to -1 of our x value, which is 4, plus c that we have. And then you are going to put now c as the subject of the formula. So that is just going to be 4 minus 1. And then that will just give a value of 3, making the equation of this line y is equal to -x plus 3. And then that is your answer. Right? So, and as you see, it is in this form, just as everyone had it over there. Perfect. And this is now 3.3 that we had. Now moving on, here to calculate the value of P. So everything else on the screen is still the exact same, but just a question that is changing. So we need to calculate the value of P, which is found at point A. So now, answers in the chat, please. Okay. Okay, so I have different answers over there. Okay, and now quite a lot of answers are the same. Perfect, perfect, perfect. So do you see all of these questions that we have actually relates to the question just above it, because you see it's all part of question 3 and it's moving on and it's moving on. Now in this case, we have just calculated the equation of AD. And the reason why that is important is because this point P is one of the coordinates of A. So that means, what do we know about A? We know the equation of it. And we just said that the equation of it is y is equal to -x plus 3. So we have it like that. Now we want the y value of A. So the y value is this over here. So we are going to put that as P because that is what we want. And then we are going to now take one of these points, and that is going to be our X value, which is this over here, our X value, right? That. So that's going to be negative 2 plus 3, which we still get from the general formula, or at least that formula that we have. And that's going to give you a value of P equal to 5. Just as everyone had it over there. Another quick, easy 2 marks done and in your pocket, ready to go. Right? And that is 3.4. Looks like everyone had it correct as well. Perfect. Now, we move on to 3.5. If the coordinates of f, so where's f? This point over here. If the coordinates of f, okay, this is 5, 2. Okay, this is actually a bit different. I'm supposed to look over there. This is actually like this. 5 over 2. All right, that's your x value. And 1 over 2. Right, that's what I actually meant there. So that means here by f, it is 5 over 2 to 1 over 2. Sorry about that. So if the coordinates of f are 5 over 2 and 1 over 2, which is off, show that CF is perpendicular to AD. Right, so CF is this line over here. We need to show that that CF is perpendicular to this line that we have. So we can have it like this. Now we know immediately when it comes to perpendicular, the first thing you should think about is, if they already ask you about that, first thing that pops into your mind, the gradients. If you multiply the gradients together and it gives you -1, it is going to be perpendicular. All right? So that is what we're going to do here. So we are now going to go look at the gradient of CF, and we're going to look at the gradient of AD. Once we have the gradients of both of these, if we multiply it and it gives us -1, they are perpendicular to each other. So let's start off with the first one, which is CF, this one over here. So we have a value of C, here is X, Y, and of our F, X, Y. So let's do the gradient. So M of CF is equal to our, this is going to be our YF minus our YC all over our XF minus our X of C. So we're going to write that out over here. So our YF is going to be this one over here. Oh, YX, sorry. No, I'm writing that. So it's YX. Yes. Oh, no, I'm going to say it's supposed to be F. It's supposed to be F. Okay. It's the Y of your F. So the Y of my F value, which is this over here. So that's a half. A half minus the Y of my C, which is going to be -3. All over the X of my F, which is 5 over 2 minus the X of our C, which is going to be -1. Right? So let's make it -1 so you can see it better. Yes, that's going to give you, if you're going to calculate that, the top will give you 7 over 2. This just shows you over its entire fraction. And if you type that in the calculator, it's also 7 over 2. This long line means it's the fraction that's separating these two other fractions. And because 7 over 2 divided by 7 over 2, type that in your calculator, and that will show that the gradient of your CF is equal to 1. Right? So we have now the gradient of our CF. But the gradient of our AD is what we have calculated earlier. So if we go back up over here, it was one of the first ones that we had. Yeah, BC. All right? So that is to our -1 that we had. And remember, we said BC, this gradient is equal to AD. Because remember, they are perpendicular to each other. So therefore, the gradient of M of our AD is also equal to -1. So that means now we take the gradient of our CF multiplied by the gradient of our AD should equal to -1. But now we're going to make sure. So if it is like that, then we know it's going to be perpendicular. So we write that out. So the one for CF was the one which is calculated, yes, here. So that's 1 multiplied by -1, and that's going to give you answer of -1. And because that the gradient is equal to -1, therefore we can say that, therefore, our CF is perpendicular to our AD. Right? And that's how you're going to get this answer. And that is worth 2 marks as well. Right? So it's always good to show you where you get to different marks. Okay, so let's see, is there any other questions in this part? Yes. Now I move on to question 3.6. Calculate the size of theta, which is this one over here. So here we need to calculate the size of theta, right? And that is going to now be worth 3 marks. So most of these was worth 2 marks every time. So let's take the ink off the slide. So let's see, can everyone please place the answers in the chat? And then we will go through the answer as well. If you feel like I've been going through too fast through the others as well, you're more than welcome to say, am I slow down, or maybe just see what's happening as well. But also another thing, remember this is being recorded, so you can go over it as well. Okay. Okay, that's fine. Okay, so I'm getting a bit slow. That's fine. Okay, so don't worry, we'll pick up now. So, okay. Yes, everyone have the answer as 45, right? Okay, some as 135 as well. Okay, so I see we might get that answer, but we'll go through it now as well. So in this particular case, what we just saw is that we calculate the gradient of our AD, which is this line over here, what is connected to our, that is connected to where G is, right? So because that is it, we know that that gradient, it was -1, right? We know where the gradient is -1, right? So in this particular case, what we're going to do is, with this angle that we have over here, right? We are going to say that, oh, let's just make this, for instance, now, we're going to look at this part from this side. As the gradient went up, so I'm going to make a part, let's maybe make it this one over here. From our x-axis, we'll make it across, everyone can see, from the x-axis over the side. I'm going to maybe call that angle alpha, right? Angle alpha. So in this particular case, we had that gradient as this, so we're going to say our tan of that alpha, right, is equal to -1 that we had. So now we're going to try and find out what is alpha. So alpha is equal to the inverse, so is that of -1. And now, if you type that in your calculator, you're going to get an answer of -45 degrees. But that's not the one that we actually want right now, because this is in a negative form. So we're going to have to make it positive. So we're going to add a 180 to it. And that's going to give you a value of 135 degrees. So there we have it as 135 degrees. Now, with that 135 degrees, we are now going to say, because this was the rest of our section over here, right? To get F, right? So it's that 45 initially, and then 180 to complete it, right? Because you know some of the angles in a straight line. So that was what F is on its own. So, okay. Now that we have that, we're going to say that F is now equals to 135 degrees. Now I'm going to take the alpha that we just had. I'm going to say that is equal to our 135, and that's going to be minus 90 degrees. And that's going to give you an answer of 45. Now the reason for that is, if we look back at our triangle, we are going to see this entire part here. So let me take off this. Erase, erase, erase. We are going to say we have this O to F to G, all right, in that triangle that we have over here, OFG. That is, F was the exterior angle. And we know if you have exterior angle, that angle is going to be the sum of the two interior angles, which is this over here. And that is why we are going to say, because it's a 90-degree triangle, we say it's 135 minus 90, making the final answer 45, like everyone had it over there. Okay, now we move on to 3.7. Calculate the area of trapezium. And this trapezium is A, B, C, and D with 4 marks. Right? This one is going to be quite of a long answer. So we'll go through it now as well. But let's just make sure everyone have this answer as well. In this one, you can run it off to 1 decimal place, right? If you have it. So answers in the chat, and we'll try and go through this. Get that 4 marks. Okay, so yes, I'm seeing everyone is getting their things correct. Good, good, good. Okay, I see someone is asking me to go back. Okay, so we have this part over here. So just to show you what I have, right? So in this case, let me take this away. Right? So they want to know the size of theta. So remember, theta is this part over here. This was theta. This is a 90-degree triangle, which is dealing with G, O, and F to that point. You see, that cuts it nicely over there, so that makes it 90 degree. So if we can calculate F, we'll know F is now 90 minus G to get to F, right? And that's how we're going to get this part. Now, the way we got to that is that we deal with tan, right? And the reason why we use tan, because we know tan is opposite over, so opposite over adjacent, all right? So we have our different values, so it's opposite over adjacent. And we said that we have it as negative 1. So is equal to negative 1. So that's going to be the opposite divided by our adjacent, which is just this one on the side, which our point is G, right? And this G cuts it on the y-axis, right? At that particular spot over there. So then we get that as negative 1 because we dealt with the gradient, all right? This, remember, we dealt with the gradient of AD. Gradient of AD is negative 1. So we took that as our line that we had over here. All right, so that was negative 1. You get the angle itself, and then from there, we put it into here. So I hope you got that as well. Fancy. Okay. Now calculate the trapezium of ABCD. So in this particular case, we saw that we proved that these two are perpendicular to each other. This line is that line, and we multiply the gradients together, it does give us negative 1, right? It does give us negative 1. So whenever you deal with the area of a trapezium, you're always going to deal with the half of the sum of your two parallel lines, and that is going to be multiplied by your perpendicular height that you have. So our parallel lines is going to be AD and BC. So it's going to be those two multiplied by each other, added to each other, and that is multiplied by your vertical height, which is CF. So we're going to place this into our formula. So in that case, we have area of trapezium. So I'm just going to write off trap, but you're going to write it out completely. I'm just going to show that we have it over there. That is going to be equal to your half, which is the sum of the two parallel sides multiplied by the perpendicular height, right, that you have. So if we're going to write that out, that actually means it's going to look like this. The area of trap, or your trapezium, right, your area of trapezium, in this particular case is A, B, C, and D, given to us over here. That's going to equal to of, remember, the sum of your parallel lines, and our parallel lines is AD, and the other one is BC. So the sum means add, so BC. And all that needs to multiply by perpendicular height, which is CF. All right, now we're going to write this over here. We'll move on. So we get this. Now, what we're going to do is we're going to get because we need to get the area of this, we need to find the length of each of these different sides. So we're going to look at it as we need to get the length of AD, BC, and CF. So we are going to now go get the one for AD, and AD's values are -2, and we calculated P earlier, which was 5. So A was 2 and 5, and C was going to be, if you look over here, C is -1 and -3. C is -1 and -3. So we're going to deal with that. So that's going to be, oh, sorry, we'll do B first. So -4 and 0. We'll come back to this over here. C is -4 and 0. Okay, so this is X value, Y value, X value, Y value. So write that down, B over there. So we're gonna have it like this. So then once again, now this is line AB that we're going to be focusing on is equal to, nice big one. That's why I have a slide like this, so for us to work out nicely. So it's going to be the X value of A minus your X value of B in this case. And all that is going to be squared plus your Y value of A minus Y value of B squared. We plug in the values that you have. So that's going to be, just to make sure again, A was -2, yes. So A was -2. Always make sure you write down the correct values. So A is always going to happen very easily. A is -2 minus 4. And let's go check B. Yeah, okay, my slides are just moving a bit around. There we go. And B, we have there's negative over there. So I'm going to plug that in as well. Okay. Remember to use line A, these two lines, and these two lines BC. So AD and BC. Which is this over here, 4 and -1. So I take that, 4 and -1. 4 and -1. Here we go. So D is the X of D, 4 squared plus Y of our A value is is 5 minus our Y of our D value is -1 squared. And that's going to put together here. That will give you a value of -6 squared plus 6 squared. That will eventually give you 36 plus 36. If you type that in your calculator, you'll get the answer of 6 square root 2 units. So that's going to be the AD. For AD, which was your first parallel side, which is this one here. Then we're going to move to BC, which is this one over here. So for BC, B had a value of -4 and 0. And C had a value of -1 and -3. And -3. So we do the same. The sum is BC. Same formula. So in this particular case is your x of b minus your x of c squared plus your y of b minus your y of c squared. That's going to be x of b, which is going to be -4. Right, so we're going to have all of that. This is the value that we got here. Yeah. There we go. We got it already. So it's this over here. 3.2, 3 and square root 2. So that's going to be this. 3 and square root 2. Then for this one, we're going to just use the last one, which is CF. That we have. C and F. So we'll just get that. We'll write all of that out. I see you guys have that already. So that's just C and F. Okay. So for C, we had it as -1 and -3. And then for F, we have that 5/2 and 1/2. Put this in the calculator right now. So that was C, F, C, F. Our x value of our C is going to be -1 minus our x value of our F is going to be 5/2 squared plus our y of our C value is going to be -3 and the y of our F value is going to be 1/2 squared. Right? That's going to give you square roots where you can have it as a -7/2 squared plus also a -7/2 squared. That will then give you a value of 49/2. Can actually simplify that a bit more, where it's going to be 7 square root 2 over 2 units. Now I'm going to write it in our formula. And remember, like I said, the formula was our half AD plus AB, right? The length that we have times our CF. Now I plug this, our values in this, so it's half. AD's value is going to be 6 square root 2 plus 3 square root 2. And all of that is going to be multiplied by our CF that we just calculated right now, which is 7 square root 2 over 2. And we're going to type that in the calculator. So then the area of your trapezium, which was A, B, C, D, is going to be equal to 31.5. If you want to round it to 2 decimal places, 0 units. But remember, this is area, so we're going to write it as squared. And yes, I saw you guys have that also over there. That's why I went back and I went to go write it down. But yes, 31.50 squared. And that is going to be now what we have for our trapezium. So, okay. Now, we're going to move on to question 4. Once we're done with question 4, and then we're going to take a short break, and then we'll move on from question 5 onwards. Right? So let's just get through question 4 now as well. So for question 4, here it says, in the diagram below, a circle with center C, which is 3 and -1, has a radius of 10 units, and that is drawn. PQR and PT are tangents to the circle at Q and T respectively. All right, so it's tangents over there. PT is parallel to the x-axis. Then R has a value of K and 21, C and P are vertices of triangle RCP, and QR is equal to 20 units. And now here they ask us, we need to write down the size of angle CQR. Oh, yes, yeah, I see people also asking what is the, okay, good. You're typing this up. Yes, the answer is 31.5, was the previous one. All right, remember, I wrote that at the end. You'll see it is, yeah, 31.5 units squared. Who is this area? Okay, so have that. Perfect. Good, good. You guys are having that over there. So you are correct. So the answer for CQR is going to be equal to 90 degrees. And the reason why we're going to say that is because of the tan radius theorem. So here we know that from the center, whenever we go from the center and we go to the side of the circle, it's going to give us a, that's the radius when it was from the center to the side. So it's going to give that, and it hits it at this point, right? This is our tangent, and where that meets is going to always be 90 degrees. So the angle of CQR, which is this part over here. So for this triangle to here and up here. So we are just going to write that, erase. Whenever we have it, radius using a tangent, we'll say it's going to be 90 degrees, and that is because our tan is perpendicular to our radius. And that's your reasoning. Now, I know that you didn't ask for reasoning right now, but yes, you are correct. Tan perpendicular to radius. Perfect. 90 degrees. 4.2. Calculate the length of RC, which is this one over here. So the length of it. Now remember, immediately when we speak about the length, here, we can speak of the distance that we have. Use a distance formula. Here they say we need to leave our answer in third form. So we'll have like square roots and things over there. All right. So 4.2, you can write your answers in that. But in this case, here you see that R does not have X value, it's K. So R's value is this, K and 21. C's value is this, 3 and negative 1. Right, so now you need to calculate the length of RC that we have. Okay, I see these answers coming in nice and fast. Good. Okay, good. So I think when we look at this, we could actually find out what the length of RC is. And how do we do that? Well, what do we know? We know that, let's get the pen. We have the length of one side. Remember, we just said Q is hitting it here. The radius is hitting the tangent, so that's 90 degrees. We have 90 degrees, and we know two sides. Therefore, we can deal with Pythagoras, right? So we can deal with Pythagoras. So in that particular case, you will always write down in which triangle you are busy with. So in triangle QRC, I'll underline that. We are going to deal with RC, which is the one they want us to find, which is our hypotenuse. So RC is equal to our QC squared plus our QR squared. Remember, if you want to calculate something that's not the hypotenuse in the triangle, you minus it, right? So it's going to be minus the square root. When it comes to hypotenuse, it's the add. That's how I normally think about it. So in that particular case, we are going to then now write this out. So it's RC squared is equal to QC, which is this one here, 10. So that is, let's take this away. I'll write that now. So that's 10 squared plus our QR, which is 20. So that's 20 squared. Now, if we want this, we're just going to square this side. We'll square these as well. So let's just put all of these, we just square all of that. Eventually you're going to get your answer for RC on its own is going to be 10.5 units. Because remember, they are speaking about this in terms of units. So when you write it down, do not forget to write units. And that's good, Pythagoras. That's the word I was looking for earlier. But yes, 10 squared. Yes, so we have it as like this, right? So square root. Why am I writing it like that? You type in the calculator and you'll get the answer like that is 10 square root 5 units. Okay, so that was 4.2. Word. Yes, yes. 2 marks. As well, someone said I was going a bit too slow, so I'll try to rush now. I was going a bit faster. But yes, so it's 10 square root 5 units. So, okay, and that is leaving it in third form. All right, we still have that over here. Now, moving on. 5.3. Calculate the value of K. So remember, that's the point within R. If R lies in the first quadrant, right? So we know this is quadrant 1 over here, right? On that side. Now, this is also going to be a bit of a long answer, and this is going to be with 4 marks. So you can place your answers in the chat. Okay, good. Okay, yeah, these are the questions coming in. I saw the answers are coming in. Good. When it comes to this, right, it links back to our, I see everyone's getting it right. That's good. But let me show now how we get there. When it comes to this, remember what we just calculated now was the length of RC. And this question is dealing with RC, or at least with R. So we know we can use that as part of our formula that we need. So we know the length, so we can deal with the distance formula in this section. So we're going to say that RC is now equal to for our two values, so it's R and C, this part here, and C, that's correct, R and C. So we're going to take a big square root, and now we're going to say the X value of R minus the X value of our C, that's going to be squared, yep, plus the Y value of our R minus the Y value of our C. And now we're going to say that is going to be equal to, we just calculated this, so that is 10 square root of 5, don't forget the square root, is equal to the X of our R. X of our R, we don't know. That's what we want to calculate. All right, that is K. So we write it as K minus KC, or at least the X of C, sorry. The X of C is going to be 3 squared plus the Y of our R, which is going to be this part over here, the Y of our R, which is 21. There's a square here, minus the Y of our C, which is -1. Square root. Okay, now if we're going to near the didn't, so we have to leave it in third form, so we can actually expand that. So that's actually going to be 500 equal to, because the reason why I'm going to do that is I'm going to square both sides. Square this and square this to get rid of this part over here. So I'm going to try and get rid of the square root. So I square both sides. If you square both sides, this squared is going to be 500, and this is now just going to give us, we take the square root away, so it's going to be K minus 3. That's the level squared. Take the square away. Come on, there we go. Squared plus my 21, and that's going to be plus 1 now, because the minus times minus is positive. So that's actually going to be 22 squared. Okay, if that's the case, we will then say we now have, if we're going to take 22 squared, that's going to give you 484. So that's actually going to be 500 minus 484 is equal to your K minus 3 squared. Now, this is a lot on one slide right now. So I'm going to be moving on, but this is what we have over here. Now, what I'm going to do is I'm going to now have to put a square root there again to get rid of this square here. So if I'm going to put a square root on the side, I have to put a square root on the other side as well. So that means it's going to look like this. We're going to have our, that's going to be 16, right? Is equal to our k minus 3. Remember, that was squared, so we put to saying square root. But now when it comes to this could be either positive or negative. And now because it could be either positive or negative, we know that this could now either be where k minus 3 is either going to be equal to positive 4 or k minus 3 is going to equal to negative 4. And now we're going to just solve this. So that's k is equal to 4 plus 3, it's going to be 7, or k is going to be equal to negative 3 plus 3, sorry, negative 4 plus 3 is going to be equal to negative 1. So it could be either of those. And then because we said that this needs to be done in quadrant 1, we know it needs to be positive. So just as everyone was saying, and just had to show how we got there, as k is equal to 7, and that means it can't equal to negative 1. And just like we had it like that, because this is in quad 1. So therefore, your answer for k is equal to 7. And that is your answer. Correct. And that is going to be worth 4 marks. Okay. Moving on. 4.4. Determine the equation of the circle with center C. So this is the center C over here. Given. Passing through T and Q. All right. So T and Q. So here's our T. And there's Q over there. Right? This spot here. This point here. Okay. So write your answer in the form and that's given over here. These are all should be squared, right? So there's a square here, and there's a square here, and there's a square here. Right, so we need to write it in that form over there. Now, when it comes to this part, the A and B values of these general equations is usually the coordinates of the center of your circle. Yes, so that should be like that, right? What I see here, someone saying 10 must be 100. Let's just check quickly. All right, now just check that should be like this, right? That's his answer. So yes, when you squared, we have like that. Oh, it should be 100. Yeah. Yes, and then we're going to get that answer. Okay, now, yes, so like I was saying, we're going to take this A value and B value, and that's going to be the value of the center of a circle. So it's this over here. So that means, even though we have it in this case, we're going to write it now using the values of C. So that means A would be equal to 3, and B is going to be equal to negative 1. But now when you place it into, remember that's exactly what C is right now, 3 and negative 1. But whenever we place into this formula, please know that the sign always changes because there is a negative in front of it. So when you place it here, right, you see the negative over there. A negative and negative. So in this case, we will then write it as, I'll write it out, y is equal to our x minus a, right, squared, remember squared, plus our y minus b squared is equal to r squared. All right, we have it like that. Then we're going to plug in our values now. That is going to be still our x, and now we take our c values. So that's going to be now, that's going to be 3 that we have over here. Squared. And that's plus our y, and our b is now going to change as well. And b is going to be positive 1 now. Squared is equal to r squared. And we have it like that. And then once we have it like this, our r was given to us. R, yeah, radius is 10. Radius is 10. So we can plug that into here. So we can just erase this and we show that is 10 squared. So 10 squared, if we write this out now again, leaving it in that general formula, x minus 3 squared plus y plus 1 squared is equal to 100. And that should be the answer. Yes, you guys have it exactly like that as well. Perfect. Right? And it should look like that. And that is how we dealt with our question 4, and that is worth 2 marks. Okay, moving on. 4.5. Determine the equation of PT. So here we have equation of PT. PT is this line here. Remember, it's now a flat horizontal line, which means the gradient is 0. It's not going like that. It's not positive. It's not going down. It's not negative. Because horizontal, we know the gradient is going to be 0, right? So that's what we have over here. So here you should get the final answer of y is equal to something. So you can type in your answers in the chat over there. Y is equal to something, right? Okay. Seeing the questions, the answers coming in now. Okay, okay. Good, good, good. Okay, yes, the answers coming in. So, okay. Before I say if it's correct or not, what we can do here is, remember I told you, so we know the gradient is going to be 0, right? There is other point that we can look at over here, and that is we can make a line, pen, yeah. We can make it from, pen, oh, yeah. So we make a line from C to T, because those are in line with each other. And here you see this X value is 3, which means the X value of T is also going to be 3, right? So that's why I can know about T as well. T's X value is going to have, it has 3 that we have over here, right? Because you see they're nicely in line with each other. We know the radius is going to be, the gradient is going to be 0, right? So M is equal to 0. Now, that means we can try and find out what if we just use a certain point on there, we can then get the C value that we have, right? So what's going to be the C value at our T, right? So what's going to be the C value at that point? Well, this is from the center to the edge of the circle. So that means that here they said it's the radius, right? Radius is 10 units. So that means that's a radius from there all the way down. But now we can't just say that, okay, T is going to be 10. The reason why we can't say that is because it's the radius, but the radius is not starting on the x-axis. It's starting a bit further down, and then you're moving 10 units. Right? So it's not 10 on its own. Right? I see so people have that over there, but remember we're not writing that as our units. So now we're going to have to see. We are going to take the y value of our C, which is this over here, and then we're going to minus it from the y value that is going to be our T. And then all of that should equal to 10. Why should it equal to 10? Because that is our radius, right? That is the amount that we need to see what is covered. So the y value of our C, which was given over here as -1, you can see it over here as well. So that is -1 minus yt is equal to 10. We make this the subject of the formula. So negative yt is equal to now 11. And then we say yt is equal to -11. That is going to be your y value of t. And then from there, you don't just say now, okay, that is your final answer as -11. Because I know a lot of you wrote that, but I do understand why you get that answer, because we're going to get there now as well. Then from here, because you see PT, which is this line, crosses through that point. We go to the general formula, which is y is equal to mx plus c. We then take the values that we have. Now remember, we said as a horizontal line, so its gradient is 0. So now we're going to write this as, we're going to have it as this as our y-intercept, which we hit as well. So in that case, we're now going to say this will just be 0. So, anything multiplied by 0 is still, anything multiplied by 0 is still going to be 0. PT crosses this line. Remember, it's in that y-intercept over here, right, at the y value. And what is the y value? We just calculated it as negative 11. So therefore, we say y is equal to negative 11. So it comes from this formula. So remember, just make sure when you do write the y is equal to negative 11, you're not just speaking of the y value of that, as this y value after you have created this formula. There we go. And that's where you get the 2 marks right there. Okay, now 4.6.1. The equation of line PR is given by this over here. Calculate the coordinates of P. All right, so we're now going to have to go through the coordinates of P. So in this case, the first thing we do is they're given to us this long value over here. Let's write it into a standard form so that we get a y on its own. So in that case, we are going to say it is 3y is equal to your 4x still plus 35. Then we get y on its own. So we divide this by 3. Come on, 3. Divide that by 3 and divide this by 3. We divide all of that by 3. That will give you an answer of y is equal to 4 over 3x. Come on. 4 over 3x plus our 35 divided by 3. I didn't want to deal with decimal places right now because we're just making it into a standard form and then we go further. Okay, yes, I see about the horizontal line. Yes, okay, there's answer as well. So, okay, remember the gradient is about the inclination as it goes up. The incline or decline, like that, right? The gradient of the line, right? If it's going up or down, saying like 0. Okay, now this is going to be your equation for PR, right? Like they have it, but in a standard form. Even though they gave it here, we have the standard form over here. So this is the part I'm going to be using, right? Nice in a standard form. Now, with this, we can know the P's y value. And P's y value was that long part we just dealt with earlier right now, where we said it's equal to negative 11, right? So this we know. And the reason why we know P's y value is also going to be equal to that. Because if we just move up again, this P's y value, you see us here, it's in line with T. Remember, both of these is hitting the y-axis here. This is where you have y. You have your number line, 0, and then, of course, you know, it goes -1, -2, and then anything in that same line, if it's here or the side, is still going to be that value. In this case, it was -11. So the y value of P is still -11. And that's why I say y value of P is going to be equal to -11. Equal to -11. That's correct. So now we can substitute this -11 into our equation that we have, which is this equation that we just made right now. So if we do that, we will then be able to find the x value, and that's what they want. They want to get the coordinates of P. So this is the value, so I'm going to have to move on to the next slide because I need more space. But as you can see, it's y is equal to 4 over 3x plus 35 over 3. So now I'm just going to plug this into here, where I use my -11 as my y value, and that's going to be equal to my 4 over 3x plus my 35 divided by 3. We'll have it like this, all right? So we can have it just like that. Then from here, we're now going to minus this cross, right? We take it across, so we're going to minus it like that. So that will give you a value, if you type that in your calculator, it's going to give you a value of -68 over 3, which is equal to 4 over 3x. Now, what we'd like to do is, we want to now get x on its own. We don't want to see what the value of x is. So we're going to try and get the value of x on its own. And in order to do that, we multiply by the inverse of the coefficient of x. So that means we're going to multiply this side by 3 over 4. What you do on the right-hand side, do on the left-hand side. So multiply this by 3 over 4 as well. Right, so remember that's not the minus now, that just means it's negative. So this is going to be multiplied with each other, and this will be multiplied with each other, cancelling these out. So it'll just be left with x is equal to That will give you eventually an answer of 17. But remember, a positive multiplied by a negative is negative, so it's negative 17. So therefore, our x value is negative 17. We said our y value is 11. So therefore, the coordinates of P is equal to, remember you always write the x value first, so it's negative 17 and negative 11. As you can see, this is a negative value and this is a negative value. Always make sure your answers is correct. So you go back to your graph. There's a lot happening over here. Let's go to the graph. Okay, so a lot happening everywhere. P is in this quadrant where you get your negative value on your x-axis and a negative value on your y-axis. So we know both is negative, so it is correct. Our point is correct. Negative 17 and negative 11. And there we go. Okay, moving on. 4.6.2. Calculate the length of PQ with reason. And this is with a reason of 2 marks. All right. Now, you guys must give this reasoning. It's going to be a nice round number. And don't forget to write the word units at the end. Right? Because they are speaking about units as well. The length is all about units. So can I get the answers for this one, please? 4.6.2. Okay, I'm not sure. Remember, it looks like this. This part, erase. In this particular case, we will be using this line, PQ and PT. What you can see from here is both of it is coming from the same point, which is P, and both of it is hitting the circle at a certain spot, at one spot, in fact. And we know that means a tangent. So this is tangent from the same point, right? So that's how we're going to deal with it. So PQ and PT has a relationship with each other because both of it is coming from the same point. So in order to deal with 4.6.2, thank you for those answers as well. Here you can see that both of it comes from point P. So therefore, we can say that PQ is equal to a PT. Why? Because tangent from the same point is equal in length. Right? So just know that's the reasoning that we have over there. So now we can say for PT, that's going to be equal to, we are going to now say that is going to be the x of our P value that we have, that is minus, let's get this marker here. Come on. Okay, sorry, this marker is just being a bit weird. Yeah, the x of our T value that we have, all right? And then we're going to take these values that we have now we calculated the one of our P right now, so that was negative 17. The one of our T, if you look over here, the x value of our T is given over here. Yeah, x of our T, remember, is this part over here, now 3, which is in line. Remember, T is over here. It's in line with this. And this is where our T was. So that's our 3. So we minus that. That was a 3, remember, it's positive 3, so don't say a negative over there. And therefore, that's equal to negative. Oh, yeah, so that's going to be minus by each other as well, right? Now, this is negative values. Eventually, that's going to be negative 20, but we're not going to be using negative units. So we'll just say it is 20 units instead, all right? So that is actually equal to 20 units, which we can't have. We're not going to be dealing with negative units for this distance over here. So what we then say is that PQ is equal to PT because they are the same. So therefore, PQ is going to be equal to 20 units. Just like you all had over there as well, right? There we go. All right, so just like that. And then reasoning, remember you say your dot, 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 reasoning, tangent from same point. Right? Point. And there we go, right? And that was this answer, 20. Now, moving on to 4.6.3. Is the area of triangle QRC equal to the area of triangle QCP? Motivate your answer. So in this particular case, we can say that they want to know, are these two the same? Is the area of this equal to the area of this? Right? Now we've dealt with the different units and our lengths as well. Remember, this is a video that you're going to be watching, where you can see all of these answers that we had in the meantime. But they want to know, are these two the same? Main thing is, yes, it is. All right? Yes, it is. But the way we're going to deal with that is because they have the same basis. They're sharing the base of QC. Right? Are you there? Sharing the space, yeah. So because they're sharing that, you can say it also have, so it has this equal height between these two, because it's the same that we have over here. And it's going to have that in common. So in order to make sure that things are the same, you just need two things to be the same. So you erase all. So remember, those two triangles is sharing this, which is our QC. So PQ is equal to that particular section, which is QR, and its height is QC. So therefore, we can say that our QC is common between the two. And that we can say the basis, which is PQ, because both of it is radius that we have, PQ is equal to QR. And because we have two that's already the same, and then we can say that the final one is how the angle looks. So you could also just say that this is going to be your side angle side. So therefore, if you have these three together, it's going to give you that both of these triangles are the same. Yes, so going to show you now, this is side angle side. So we're going to look over here. Okay, so let me show you what I mean by this. Boom. This part here have the same height between the triangles, right? Sorry, the same base. This is what. Come on, let's move. There we go. Sorry, this mark is being a bit slow. This is the base between both angles. So what are the same? Same base. What is the base? QC. Right. One similarity done. An angle is the same. What is the angle? Here is. This goes from here. On both of it, in both triangles, it hits it over there. There's a radius, it hits it at a tangent, which means on this side it's a 90 degree, and on this side it's a 90 degree. So our second one is an angle. Is the same between both of these. We need one more similarity. We then look at this part. Let's take this off. Away, away. Bring this back. We have the center of the circle, and both of it is going all the way over to here and all the way over to here. So the length between these are the same as well, right? So the length of our RC is equal to the length of our CP that we have over there. Right, so it's just like this. Oh no, sorry. The way you can put it is the length of these two. Yeah, PQ, this one, and this one are the same, because you have the center and it hits here. It will split your tangent or split the line in half. Remember, making it the midpoint. So therefore, PQ, which is this side of the line, is equal to QR, which is this side, because it went from the center and hit that line on the edge, right? And because it's perpendicular, means this side, PQ, is equal to that side. I hope you understood that as well, right? So same basis, QC. Same angle, because it's 90 degrees. Radius, from the center, hitting the edge. And then the final one is the lines where it joins over here, PQ and QR. And that's how I get it. Okay. So, okay, now we'll go to 4.7. Consider another circle with equation, and it's this over here. Once again, this should be a square. This is a square. Is equal to 16. And having a center of M. So write down the coordinates of the center M. Right, so if it has a center M. Remember, I told you the values. This is the general form that we have over here. So this would be the X value of your center of your circle. This will be the Y value of the center of your circle. So that means the coordinates for M is going to be perfect. You have it already. You swap the sign, so it's 3 and a 16 over there. So you write negative 16. Bam, done. 1 mark. Easy does it. Write down the length of the radius of the circle with center M. So now we know the general formula would have this as R squared, which is 16. So here we're saying that R squared is equal to 16. But they want the radius, which means we want R on its own. So we square root both sides. Therefore, R is equal to 4. Right? Yes, 4 units. Another mark, just like that. Done. Perfect. And you guys have it as well, just like that. Now, moving on to the last question in this part, and we'll take a short break. 4.7.1. 7.3. Prove that the circle with center C and the circle with center M does not touch each other or intersect. Now, this one, the way you can think about it is that if you have 2 circles, let's say, for instance, we have a circle over here and one that's not touching it, so maybe a smaller one over here. Then you say, let's say you have the center of the one here and the center of the other one over here. The distance between these two, maybe this can be M. This is circle C. The distance between these two from here to here. The distance of that would be more than the radius of the one. So maybe this is R1 and this radius is R2. So if we should add radius 1 plus radius 2, it should be less than this distance over here. Then we know that it won't be overlapping with each other, because as you can see, radius 1 is only this part, radius 2 is only that part. If you add it together and it's less than the total amount, we know that's how it's going to be. Okay. Okay, so yes, so we have it just like that. Now, let's show you how we do this. So we're going to dealing with M. So we just calculated the coordinates of M. So M's values are 3 and 16, we just got in the previous slide. And then we go with C's values because we want to deal with the centers of circle of C. And the reason why we're dealing with the center of circle of C is just to make sure that everyone's following along, is here with our this part, which is this circle here. This is circle C with the center as C. So we're dealing with M versus C. And points of C was, C is 3 and negative 1. 3 and negative 1. So we're going to find the distance of this. So the distance of MC is equal to square root. Wow. So we have it as the of our M minus the X of our C, and all that is squared plus the Y of our M minus the Y of our C. And that is equal to all this over here. So X of our M is 3. That is 3 minus 3, which is our C, yes, squared plus Y of our M is 16, minus the Y of our C, which is negative 1, squared. we're going to type that in, and then you'll see that MC has value of 15 units. So that is the length of our MC. So if that's the length of our MC, we move on to the radius. Radius 1 plus our radius 2. Now, for this particular section, for your radius 1, it is 14 and the other one is 10. All right, and that is given over here. So, yeah, see, 4 is the radius of our circle with center M. And then by now, everyone should actually have seen it already because it was given in the question. So I just want to show everyone so no one is left behind. Radius of circle C is 10. So therefore, now we add those two together, 4 plus 10. So I use this as my radius 1. Yes, of circle M. So that is 4 plus 10 is of course equal to 14 units. So because these two radius is 14 units and the total from M to C is 15 units, therefore we can say that the distance of MC is greater than the distance of the sum of these two radii, therefore making it, or therefore we're saying that it does not overlap with each other. Okay, there we go. That's correct. So see, 15 is greater than 14, therefore the centers do not touch. Okay. Okay, so okay, Vivuyo, let's just explain for a short bit and then we can take a short break. Remember the total distance between the center of your circles is this one here and this one here. So that line goes from here all the way to the side, right? And that distance is 15 in total. But what is the distance only of R1, which is from here? And what's the distance of only R2, which is from the center to the circle, is this part over here. That is 14. If that had to overlap with each other, the circles would have been like this. The distance of the one would have gone till here, and the distance of the other one, let's say it would have been here, gone to here. That values, if you had to add these two up, it would have given you a smaller number than you see when it is separated far apart from each other. There we go. Okay. Okay, and that's how I get it, right? Yeah. Okay, so okay, I see you have it over there. Yeah, you guys are saying it's negative 16. Are you sure? Because just check the values that was used. And the values that we used was, yeah, we had it as 16, that's fine. But remember, that's not that's the value of our y-intercept, right? That we had over here. And I placed that into it as well. That's our y-intercept. So yes, minus 16. Yeah, our value of this 16, y-intercept is here. Okay, so guys, I don't want us to run too late over because I mean, you have a test on Monday. So I'm going to take a short break over here. Then we'll continue with the next sections. Remember, that's going to be dealing with trigonometry and geometry. Right? So it's going to be quite a hectic topics. So we'll take a short break. Let's make it about a 10-minute break. Be back at 11, quarter past 11. So 11:15, starting on the next section. If you go out, just use the same link. If not, you can leave it in here as well. Thank you. Hello. Okay. Good day all. Good day all. And welcome back. I hope you guys had okay short break. I know it's a very short break, but just so that we don't take too much of a Saturday to give you more time to watch this lesson. Remember, this is also recorded, so you will be able to get that again as well. So now we're going to be moving on to question 5. Remember, now it's just going to get more difficult because this is trigonometry and Euclidean geometry. Unless you are very used to this, then it won't be as difficult. But now let's see what we're going to be doing. Same thing is going to, we're going to be covering or doing these questions the same way, where you give answers, and then I'm going to show you how to do it as well. If you have any questions, you could ask as well. I see your question there everywhere. I will get to that at the end of the lesson. We just try to finish this paper, and then I'll try and answer any of the other questions. Okay, so now let me just get my marker out once again. To make this a bit easier to work with. So here we go. Okay, so here it says 5.1. If sine 14 degrees is equal to P, without using a calculator, determine the values of the following in terms of P. And here it says cos of 76 degrees. Now, before we carry on with that, always answer this, what is given to you right now. Sine 14 is equal to P. So there, I see people already giving answers. Thank you very much. But to show how we get there, remember your SOHCAHTOA or TOA with an A. So how we deal with that is we'll make our triangle. We're going to deal with this first quadrant right now. I'm going to go like that, like this. You have your 90 degrees. Here's the sine of 14. So we make 14 over here, 14 degrees. We know SOHCAHTOA, so it's opposite. We're going to deal with this opposite over hypotenuse. So the opposite is going to be P. Hypotenuse is going to be 1, because that is just P divided by 1. So we know that is this particular section. Then in order for us to calculate X, which is our X value over here, all we're going to have to do is we're going to say so this top section over here. So let's take this away. We'll just take that part. At least we know that is what's happening. We are going to use our pen again. So we can say it's x squared plus y squared is equal to r squared. So in this case, we already know what this is. So our x squared is equal to our r squared minus our y squared. So what is our r squared? Well, it's 1. So it's going to be 1 squared minus our y, which is this value. Our y value is p. So that is y squared. And this is our x squared. We want x on its own, so we square root. We put that in the square root. We put this in the square root. So then that means x is going to be equal to the square root of 1 is just 1. So that's 1 minus, and this is y is p. So we're going to write that as p. So p squared, we'll leave it as that, right? Our p squared that we have there. Right? So we have this entire part over it like this. All right, so we have it like that. So that's going to be our x value. So this is going to be 1 minus p squared. So we take everything else off the slide. Right, so that's how we're going to get this value over here. Okay, now that you know what our values are of a triangle, there's one more that we can find out. And I know some people like calculating it now at the beginning as well, and it is this angle over here. We know angles are always equal to 90 degrees, 180 degrees. So we are going to now use the sum of the triangle. So we are going to now say that angle, which is on top over there. So we'll say that is going to be our 180 minus our 90 degrees that we have, minus our 14 is going to give us that angle. And that angle is going to be equal to That should be 76. Yes. Type it all out in the calculator, and it's going to be 76. So this angle here is 76. Right, so we have that. Let's just place it in here. So everyone can see 76 degrees. And look over here, our first question, 5.1.1. We need to calculate cos of 76. So that is cos of this. And we know cos is adjacent over hypotenuse. So adjacent is usually next to it. So that is going to be P over 1. So therefore, that answer is going to be cos of 76 degrees is equal to your P, which is your adjacent over your hypotenuse is 1. So you can also just say it as cos of 76 degrees, even though it's P over 1, it's just P. And that's where everyone got it as well. All right, so just like that. Perfect. And yes, you could also do it as sine 14 when you deal with the other part over there, but we're mainly going to focus on in terms of P. Yeah, the one in terms of P. So yes, that's correct. That's where you get to 2 marks. Moving on. 5.1.2. What is this in terms of cos 44? Now, cos of 44, here you see it's not worth 2 marks, it's worth 4 marks this time. Now, here we need to think, how do we get 44? Well, 44, we can make this eventually add up, right? What values can make us? Do we know anything special that we can get with 44? Well, yes, we know of special angles, right? You know where you get 30, 60, all these different ones over here, right? So we can actually do that. So if we say here, this is going to be equal to our cos of 30, but cos of 30 plus how much will give us 44? Well, that's going to be 14 degrees, right? So we're going to have it like that. And now that we have it, we can use our compound angle formula. Right? Now we can use a compound angle formula. And when we use a compound angle formula, it's going to be like this, where we separate different parts now, different sections, which is 30 degrees and 14 degrees. Now, using the compound angle, it's going to be cos of 30 multiplied by our next term, which was cos of 14 degrees. And that is going to be minus the sine of our 30 multiplied by the sine of our 14. Remember, this is given at your formula sheet, right? So we can deal with the compound angles. So here we have the section over here. Now you're just going to try and expand all of this. Cos of 30, using our special angles, we'll see that that is actually square root 3 over 2. Our cos of 14, we'll get from here, right? Here is our 14. Erase. That is P. Okay, this is P. Remember, cos of this, so it's adjacent over hypotenuse once again. So here we're just going to write that out. So let's just focus on that as well. So here we said it's a square root 1 minus P squared all over our 1. Remember, it's going to be the exact same, which that's a hypotenuse, adjacent of hypotenuse. Now we say minus our sine of 30. Sine of 30 special formula will give you 1 half, right? Special angles. And then we deal with sine of 14. We go back, sine of 14, opposite over hypotenuse. So that's going to be P only. So we can also just make sure, because everything else is in a fraction, so we'll just write it as a fraction still anyway, P over 1. But if you write it as P, it is still fine. Now, we have a minus separating these two. What we could do here is, when you multiply this across, you could use your third rule. Now, when you deal with the third rule, that is going to be when you multiply these two square roots together, and then you put what is in the square roots, they can be multiplied with each other. So it could look like this. So you leave your square root over there, and then you're going to say it is 3 multiplied by your 1 minus P squared, right? Like that. And all that is going to be divided by 2. Because remember, is this 2 multiplied by this 1 over here. There we go. So we take that away. And then we do the other side as well. So that's going to be minus 1 multiplied by P. It's just P. And then 2 multiplied by 1, it's just going to be 2. So it's going to look like that. Now we have this minus from each other. What is the same here? Can we do anything else? Yes, we can. Both of these has a 2 as a denominator. So we place the 2 over there, and then we can put the other things together. So this negative P is going to go over here. Too much on the slide, so we'll write it like that. So your final answer is going to be negative P plus your big square root that we had, remember, using the third formula, is going to be 3, 1 minus P squared, all over our 2. There we go. And that is going to be what your cos of 44 degrees is equal to. And see, it is still in terms of P. There we go. All right, so that's how it's going to be. That's how we dealt with 4.1.2. Now we'll move on to 4.1.3. If sine, which is the same as we had in the previous one, sine 14 degrees equal to P, without using calculator, determine these values. Where it is 2 multiplied by sine 218, and that's multiplied by cos of 38. Now, if we look at this, the way this formula is written, 2 times sine multiplied by cos. That looks similar to something else that we have all done already. So what we're going to do now is that looks like our, let's just check. Yes, that looks like our double angle formula. So this is the double angle formula. All right. And remember how a double angle formula works is your 2 times your sine, like you usually have, and that's multiplied by cos. But remember, you need your value, so it's 2 times sine x multiplied by cos x. In this particular case, here we have a 2, we have the sine, this is going to be the x, this is multiplied by our cos, and we have our x. So you see, these two look very similar to our double angle formula. 2 times sine x cos x. So we're going to work on that basis. But now we can't just make an answer from with what we have here, because this value, 218, is way too big. So we need to reduce that value. So let's reduce that first. So now what we're going to be doing is we are going to write it as we have it here, 2 sine. How do we reduce it? Now remember, that's when you have your cos diagram. Here is, we know already by now, this is 0, 90, 180, 270. And then this is going to also be 360 over there. Where do we find 218? It's in quadrant 3. And that is usually going to be our 180 minus theta. I know everyone knows this by now, but just showing you where you get this. So that is now going to be 180. And what will give us 218? That is going to be 38. Sorry, or plus. Yeah. Was minus is basically in quadrant. Plus 38. And then we still say multiplied by our cos of 38. So, okay, we have it like that. Now we go and we write it, our 2 equal to sine of this. So, okay, when we reduce it, we are now going to say it as, this is in quadrant 3. Now we know this is the cos diagram, C-A-S-T. Sine is negative in the third quadrant. So it's negative sine of 38. And that's still multiplied by our cos of 38. Hey, look, those two are the same. So far, so good. Now, now we see we have equation like this over here, right? So it's 2 negative sine 38 times our cos of 38. So I'm just going to take the negative out. So let's write like this rather. Negative 2 sine 38 times our cos of 38. Now this looks very similar to this formula that we normally have. 2 sine theta times cos of theta. If you have it like this, right? This is the double angles. Where you normally have it, we can write this as sine 2 theta instead. Right, so this is the double angles that we have here. Sine 2 theta can be like that as well. If you look, this looks very similar to that. So what we're going to do is we are going to take this as our theta. Our 38 is going to be like our theta, just like we have over here. All right, everything is the same. We're following this. All right, so we're following that double angle formula. So I'm not going to take it off the slide. I want you to see where I'm getting that. So now I'm going to say that is equal to our negative. What comes there? It's our sine. So we write sine first. Then it becomes the 2. So we write out 2. What's the angle in this case? 38. To make it different, you write it as 38 over there. Good. Now, we're going to work this out, and then we leave it as our negative, because remember, it's still dealing with that quadrant. Negative sine is going to be 76. Why? Because you're going to deal with that 38 squared. All right, so it becomes like this. Now we have it as negative sine 76. Do we leave it here? The answer is no, because we need to make this in terms of P. I don't see any P there. That's because if we go back to our graph, here is our 76. So now we deal with our sine of that 76. Remember, your negative is still going to be, don't forget to carry your negative over. Sine is opposite over hypotenuse. What's the opposite of this? 1 minus p squared. Sorry, the square root of 1 minus p squared over 1. And that's going to be our answer. So our final answer here is going to be equal to, keep our negative, square root 1 minus p squared over 1. And that's where you get the 3 marks. And it's also in terms of p. Negative, yeah, root 1 minus p squared. Good. I see you guys have that as well. Good, good, good. 5.1.3. And that's how we got that. Right? It's quite a bit of work, but that's how I get there. So just make sure you know your compound angles and your double angles as well, and relate all of this together. Moving on. 5.2. Now, in this particular case, we have this given to us. Given to us is 1 plus, we have our sine 90 plus theta, multiplied by our cos theta minus 360. Remember, that must ring bells here for you when you see that as well. That means we're going to have to add 360. But the first part, that means you're going to have to check how that goes, right? Normally when this comes to 90 plus theta, remember it swaps signs, it goes over to like a cos, and then you're going to have to say if it's positive or negative. And then we have the rest of our equation over here. Then they ask us for 6 marks. Simplify to a single trigonometric ratio of theta without using a calculator. So, okay, now you can't just type all this in a calculator and see if you can get an answer. I mean, how are you even going to start doing that by typing this in a calculator? So what we're rather going to do is, the first thing is, we know our cos diagram. Like I said, we add 90 over here. This would be theta plus 90, all right? So that means this is in the second quadrant, quadrant 2, right? Our second quadrant. So what is sine in the second quadrant? We know sine in the second quadrant is going to be positive because of the cos diagram. Right? But because it's the plus 90, it's going to change to cos. So do not forget your 1 when you're doing this problem. So let's say that's equal to 1 plus. We deal with this first part over here. I said this is going to now change to cos because it's now 90 plus. So it's going to be cos of theta. And sine is positive in there, so we leave it as that. And then we say this is multiplied by, we take this erase. Then we look at this next one. Theta plus 360. Because remember, when it usually comes to the cos diagram, you have your value before your number. This is the other way around. Do not get confused by it. So if you say 360 negative 360 plus 360, it's just going to give you theta. So in that case, it's just going to be cos of theta. All right, and that's going to be positive as well. Okay, now we're going to say all of this divided that we have over here. Right, so we have this. Now we look at, okay, now we're going to go to this part over here. Sine of theta minus 30. So, okay, sine of theta minus 30. So here we're going to write that as we have it. So that could be cos theta, sine theta. There we go. That makes sense. So this is going to be almost like we have as our sine A minus B. I might be thinking, whoa, what does that mean? If you look at this formula, when you expand it, it's normally sine of A times your cos of A, right? Minus your cos of A times your sine of B. All of that is what this is related to. So this entire section that I have here is actually similar to this over here. Let's move along. Sine, then this is of A, right? So that is A, times cos of A. Okay, so that's like our cos of A that we're going to be dealing with. Oh, sorry, cos of B, yes. So cos of B, yeah, cos of B. And then that's sine of A, the sine of, yes, cos of A, which is this over here. As you can see, A is our negative 30 that we have. So that is A. And this is our B. So that is B. So B is always theta in this case, and A minus 30 is going to be our A's. And even though these are swapped, like it is over here, this is cos times sine B. Here is a sine times cos. Remember, when you're multiplying things together, it can be interchangeable with each other. Therefore, that means we can now change this entire denominator to look like this, where we have it as sine, and we're going to write our A value, which in this case is now going to be our theta minus 30 degrees. And then we go, now we have that part. Now we're going to say, sorry, now we're going to say this part minus, what was our B? Our B was only theta. So that's going to be our B over there. Come on. Our B is theta. All right, only theta. And that's how we have this so far. So far, everyone understand what's happening. How did you simplify? Change the angle to... Oh, okay. Wait, so what happened here was, I didn't simplify it to positive 360. What I done here was I needed the number, well, yes, I needed the number that is 2 theta. I needed that positive. We don't deal with negative numbers because remember, when it comes to the cost diagram, it goes from 0, 90, and then 180 and 270. All of these are positive. But this is theta minus 360. So it's not even on the cost diagram yet. So what we needed to do was we needed to bring it over to the cost diagram. And when it comes to the cost diagram, let's say you have a point here and you add 360 to it. You will make it positive, so it's going to go right around. And the reason why we say 360 is because you will get to the same point. Remember, you'll have a revolution. So all I done there was I added 360. And that's why 360 added to negative 360 will just cancel it out. And that's why I was just left with the theta over there. Hope you understand that now. Cool. Okay, now, here we have this part, right? I hope everyone is still doing okay with this next section. Okay, now we have our, there's a cos, so it's 1 plus cos theta times cos theta. So those are the same. So cos theta times cos theta will be cos squared theta. All right. And in this case, what else can we simplify here? Well, if you multiply that, this can cancel with this. So that will be equal to 1 plus cos squared of theta all over our sine 30. But that's negative. So we put a negative in front, negative sine 30 degrees. Right? So far, so good. Pleasure. So far, so good. So we'll have it like this, right? Now, can we go further? Yes, because when it comes to this, let's see, 30. 30 is a special angle. So when it comes to a special angle, we know that is actually half. So I'll move on to the next slide. So that is now going to be, do not forget your 1. 1 plus, right? Wait, no. Yes, I'm first going to show you now just to have everything on the same slide. Our cos squared of theta all over our negative sine 30 is going to give us our negative half over here. But now, in this particular case, I'm going to try and do two things for you. I want to show you. This is a positive, that's a negative. We know positive and negative is going to be a negative. So what that could actually mean is, if we now take that away, positive times negative is a negative. So we take that away, and now I show you it's going to become a negative. So it's actually 1 minus this. And if that's the case, we have it like that. So see, it both means the exact same. I just wanted to show you positive times negative will give you a negative. Now, instead of just having the negative at the bottom, you move it to in front of the fraction. Now, we want to make this as simplified as possible. So let's get rid of that fraction. Now, in order to get rid of that fraction, we have a fraction in the denominator. So we are going to multiply this by 2, right? So we're going to multiply by the inverse that we have over here. So because we're going to multiply this bottom part by 2, what you do at the bottom, we do on the top. So multiply this part by 2 as well. So that is going to now be equal to 1 minus 2 cos squared theta. This got rid of this. So that's why there's no more fraction. So we're only there, right? So now we have this. Now, this again looks like a double angle. Usually the double angles look like this. 2 cos, come on, write properly, 2 cos squared theta minus 1. That is how your double angle usually looks. But this doesn't look exactly like that, because look here we have this negative 2. 1 minus negative 2 cos theta. So we want to make this look the same, because let me just write that there so people do not forget. Remember, that's a double angle, right? That we have over here, double angle formula. That's where I got it from. So we're going to take the negative out. And when we take the negative out, now we can say that is 2 cos squared theta minus 1. Because remember, if you're now going to multiply that inwards, you will get that normal, you will get the line above this, right? So, okay. Now that's our double angle. But our double angle is for this top part is the same as our cos 2 theta. That's the double angle. But now we can't just write it like that because we have a negative over here. So our final answer is negative cos 2 theta. And that is how we got this answer. That was 5.2.1. And that was worth 6 marks. And that's where we go. So as you can see, please make sure you know your compound angles, special angles, double angles, and all of these. Okay, so now we're going to move on to 5.2. 5.2.2, sorry. Write down the maximum value of this that we have. And that is only worth 1 mark. Now you're probably thinking to yourself, why do we have such a long expression over here and the answer is only going to be worth 1 mark? That is because we've done most of our calculations in the previous question. All of that eventually added to, or at least it turned out to, negative cos 2 theta, right? That was what our expression simplified to. They want to know what's the maximum value of this expression. So we basically want to find out what is the maximum height that this graph can go. Now we know for a cos graph, because as you can see, this is a cos graph, right? This cos. We know a graph comes like that. It goes like this. Usually cos graphs go from 1 to -1. Remember the amplitude or the height? That is denoted by this part over here. there's no number over there, which means it still has the same height. So remember, cos graph starts by 1, eventually goes down, goes around, and comes back up. So this particular case, what's the height or the maximum value that we have? It's going to be 1. So all you have to say over here is, your answer is 1. And that's where you get your 1 mark. Everyone understand? Perfect. And that's why it's just worth 1 mark. So you have to know the background knowledge for it as well. So, okay, now moving on to 5.3. When it comes to 5.3, it's no use I tell you guys now what was your answer, because we literally have to prove left-hand side with right-hand side. So you can just say 3 minus 4 sine squared x, and that's your answer. Or you can say the other way over here. Are we aware? Okay. Are we aware? Maximum height basically refers to your range. We're speaking of the range. So what's the maximum value is basically the maximum height that this can go to. All of that is a cos graph. So don't forget to learn about 3 graphs, right? Remember, sine graph starts at 0 and goes up and then down. Cos graph starts by 1 and it goes around like this. Depending on where you put your number in your equation for your sine graph, tan graph, or cos graph, it will affect it by stretching it, expanding it, translating it, moving it, or shifting it. That's the words also, yeah. Shifting it or stretching it like that. In this case, remember, we just shown you that we got this answer. Yeah, we need to simplify this entire ratio, and eventually, when we finished it, we saw that this was our answer, which means it's a cos graph, right? It's cos. So what's this range? What's this highest y value that this can go to? Was that's what I mean by this maximum value? Then you think, okay, you look at the expression of this graph. It was negative cos 2 theta. The number in front usually depends on how high to go. If it was 2, this value would have been 2. If it was 3, the value would have been 3. So what's the maximum height? 1. The negative is just that bottom. Remember, so negative 1 and 1, right? The same over there, right? Negative and positive. So, yeah, that just shows, remember, we'll swap it now, right? So that we have our negative on the side. So, okay, leisure. Now, let's prove this. 5 marks. This one, let me just, sorry, I just take a sip of water quickly. This is going to be worth 5 marks. I'm going to choose the left-hand side to make to the right-hand side. And now, let's move on. Because we're dealing with a fraction, I'm going to choose the left-hand side for the one for us to calculate. So, left-hand side. Please always state to the examiners which one you are starting off with. So, left-hand side. Left-hand side is sine 3x over sine x. So, can we expand this further? It's not sine squared or anything, but what we could actually do is we could say that this is sine, if we say it's 2x plus x all over sine x. That is sine 2x plus x is the same as sine 3x. So I made it a bit longer. But this is now a bit different because this is like our compound formula again. As you can see, we're using these compound formulas a lot. So make sure you know how your compound formulas is. Now we're going to expand this, where we're going to have this as our A, and this is going to be like our B that we have there. All right, so our A and our B. So, okay, now we're going to write this further. I'm going to change it, and this we're going to now make it as sine 2x times cos of x plus our cos 2x times sine x. All of that is from the compound formula, and all of that is now going to be divided by our sine x at the bottom. right? We have that so far. Now, this sine 2x, you can rewrite it where you put the 2 in front. So, take a mental picture of that. Remember, you have the video that you can rewatch again. I do not have enough space. It's going to be quite a lot of slides. I can't rewrite everything all the time, but just keep up. So, that's now going to be equal to 2 sine x times our cos x. And that is going to be multiplied by our cos x. And then all of that is now going to be added to our 1 minus our sine squared x. Sorry, 1 minus our sine 2x multiplied by our sine x. And all of that is going to be now over your sine x. All right, so now just expanding what we have. Because we have this 2x, and I'm going to expand that. And then when we have our sine 2x, we are going to now make it like this. So just to show you where you're following along, this was the initial sine 2x that we had, and then we expanded it to sine 2x multiplied by cos x, right? With the rest of it. Then we took that and we expanded it again to the spot. So that's where we get our other cos as well. Now, this is now going to be, now we're going to write it out like that. So we're going to have this 2 sine x, these two multiply by each other. So that's going to be cos squared x plus our 1 minus 2 sine squared x. Remember, now just dealing with like the spots over here, multiplied by our sine x. All of that is going to be divided by our sine x. Now, you might be thinking, whoa, where did we get this spot? The reason why we got this spot is, if we go back up, this was this compound formula. Cos 2x. We are changing it. We're changing this cos into in terms of sine, because look, our right-hand side is going to be dealing with sine. So that cos 2x, I expanded to 1 minus 2 sine x squared. And that's where we got this section. So I put it in terms of sine. Yes, I thought that's where you got. So, okay, that's how we go, right? Now, we get that. And now we are going to write this out. What is similar between all of this? Well, we have a sine x here and a sine x here. We have a plus in between it. So we will, the second cos x, I just expanded it as well, right? Using a compound formula. Okay, now we are going to now write this out. We take sine x as our common factor, and we put in brackets what we still have left. The 2 is still left there, times our cos squared x. And that's now going to be added to, this is still our 1 minus 2 sine squared x. Do not forget, all of this is still over sine x. So we have it like that. Now from here, we can cancel this with this, so we're just left with this spot. So now I'm going to rewrite all of that on my slide right now. Now, before I rewrite this, this is 2 times cos squared x. I can change that up again. So when you have 2 cos squared x, we're going to change it up now. And that's now going to be 2 times 1 minus sine squared x. Because remember, we want all of these. It's the same like I done earlier, where I wanted cos in terms of sine. And that's how we get it. Plus what was left over here, which is this section here. 1 minus that section. So we're going to write that out again. 1 minus our 2 sine. 1 minus our 2 sine squared x. Okay, we have that. Now, we have different expressions. Here's a plus, here's a minus. Right? But before we go further, this can still be placed into here. We can multiply this together. So let's take this away. Okay, that doesn't want to erase, so let's just leave it there. So we will say 2 multiplied by 1 is, of course, 2. Then 2 multiplied by sine squared x is going to be negative 2 sine squared x. And then this is plus 1 minus 2 sine squared x. Here's a different terms, a minus, a plus, and a minus. We have like terms. Here is this 2 can be added to that 1. So that's going to be 3. This minus 2 can be minused with this minus 2 as well, because it's just doing like terms. So that is actually going to be minus 4 sine squared x. Can we make that simplified anymore? No. So that is 3 minus 4 sine squared x. If we move all the way up again, 3 minus 4 sine squared x. So we got our right-hand side. Therefore, you can state left-hand side is equal to right-hand side. That's where we got our answers. Okay. Okay. Now, 5.4. Guys, I got it using the compound formula, right? That's where the other sine squared, that's where the other cos come in. Determine the general solution of the above equation, 5.4.1, worth 5 marks. So that's going to be 5.4.1. Now, this is what was given to us, sine squared x plus sine 2x minus 3 cos squared x is all equal to 0. So what you could say here is, this could be expanded, this one here, sine 2x. Right, so sine 2x can be expanded. Now, I want to show you guys this, how you can expand these different parts. So in this, if we're going to write that now, sine squared x is the sine squared x. And then we add it to this part that we're going to now expand, which is going to be 2 sine x. And that's going to be multiplied by our cos of x. Right, so we had it like this. And then from there, we're going to say that's going to be multiplied by what we still have left over. Minus 3 cos squared x. All of that is equal to 0. Now, if we look at what we have here, this is actually a quadratic equation. How do we know? Well, firstly, we see it's equal to 0. We also know that when we have a quadratic equation, it is our ax squared plus bx plus c is equal to, here in this particular case, is our a, because you know sine squared x can also be written as sine x squared, is equal to, this is our b, boom, this entire part, and this is our c. All of it is equal to 0. So that is like our quadratic equation. So now that we have this as a quadratic equation, we know whenever we have a quadratic equation, we need to factorize. So let's factorize the sine x squared plus this 2 sine x times cos x minus 3 cos squared x. So this is now going to be, we put our brackets to factorize. 1 this side, 1 that side. Good. How do we get our sine squared x? Well, that is going to be our sine x multiplied by sine x. Good. How do we get our cos squared x? It's going to be, of course, come on, marker, there we go. Cos squared x, so it's going to be cos x multiplied by cos x. But that is 3 cos x, which means we're going to have to put the 3 in front of it, because 3 times 1 is still 3. I'll choose the 1 on the side. But now, what are the terms that we have? We have a plus and minus. So that means in one of our brackets, we're going to have a positive, and one of it, we're going to have a negative. Now, because the bigger number is over here, all right, that is going to be, the bigger number will have the positive section of this term. So it's going to be plus here and minus here, right? That big number is going to have the positive section. So if you're going to multiply all of these out with each other, remember this, of course, for x, cos x, cos x, that will give you the top part. So this is how we're going to factorize. So sine x plus 3 cos x, and then it's going to be multiplied by the other side, sine x minus cos x. Now that we have it like this, we are then going to now simplify both of these. As you can see, both of it has a sine x in it. Here's a sine x, and here's a sine x. So we're going to have to solve both of these brackets. So now I'm going to move on to the next slide. All I'm going to do is I'm going to now say I'm going to make sine x the subject of the formula in this side, sine is the subject of the formula of that side, which means it's going to be sine x is going to be equal to our negative 3 cos x. If you look over here, it's because we're making it the subject of the formula. All right, so it's going to be now negative 3 cos x. Or we do the same for this one, where you make x the subject of the formula. So in that particular case, you see x is negative here, make the subject of the formula. So it's going to be sine x is equal to negative. Sorry, it was negative, so it's cos x. There we go. Right? So it looks like this. Okay, now we want to make this as simple as possible. So we are going to try and get rid of this side. So we're going to divide this side by cos, which means we're going to have to divide this side by cos as well. So if we're going to do that, we know sine x divided by cos x is identity. So we're going to say sine x divided by cos x is tan x. And that's equal to, these cancel, negative 3. Or we do the side now. We are going to have it like this. So once again, we're going to try and get rid of this cos over here. So we're going to say this divided by cos, this divided by cos. So if that's the case, again, sine x divided by cos x is equal to tan x, just like the other side. And here, cos x divided by cos x is 1. Now, we are not done. So we're going to move back to the left-hand side. If we make the left-hand side x subject of the formula, so x equal to a tan minus 3, and that is going to be equal to, if you type this in your calculator, negative 71.57. Now we're dealing with a general formula, so that is going to be plus k multiplied by, it's a tan general formula, so it's 180. K is an element of the integer. So that is the section here. Right, so that's that section over here. Next, we deal with this one over here. We do the same, where we say x is equal to, we make it like that, to 1, and that's going to give you a value of 45. So now we're going to say that is 45, or it is x, is equal to 45 plus, just like we have earlier, k 180, k element of an integer. And that is how we dealt with 5.4.1. All right, and that is worth 5 marks. Right, so I have it like this. Okay, does everyone understand how I got to this part? Okay, moving on. .4.2. So, okay, now that is still given like we have the previous one. Hence, or otherwise, determine the values of x in the interval of x, the element of -90 to 180. And they're saying it's included. Remember, these brackets mean it's included. All right, it's not a circle bracket or half circle bracket. So here we already saw that if x, so if we move up again, if x is equal to -3, right? If x is this, we will have this value, negative 71.57. So we know that's one value. If x is equal to 1, we'll have it as this here, all right? Or at least that tan part, to 45. So, sorry, no, this is when x is 0, right? So with tan is 0, just place it as 0. That's equal to either negative 71.57. That's if you're going to place a 0 in here, all right? If you put the 0 here, put a 0 there, it will just give you negative 71. If you just put a 0 here, it will just give you 45. Now we're going to see what other solutions can fit into it. So here we know that if our k was equal to 0, then, or at least let me write it down. Then x will be equal to, we said, negative 71.57. Then you move on, and we're going to show now that if we have it as k is equal to 0, then x is equal to 45. Yeah, so you're asking, did we work in the second and fourth quadrant? In this case, remember we didn't decide it. This is the part where we're going to say which quadrants, because here they actually tell us the interval, -90 to 180. You have your cost diagram. Remember, -90 is not even on here. And then we move on. Here is 0. And then here is your 90. And here is your 180. Right? So it can go all the way around. Another thing is, think about it as your graph that you have. Remember, this is still, both of it is dealing with trigonometry. -90 is maybe about here. And then you have 90 here. You have 180 here. But remember, because this is a tan graph, you would also have the 45s, right? -45s. In this case, they are speaking of the -90 section to the 180. We, of course, have asymptotes between this, but we'll get there. But I was just answering that person's question over there. Now, moving on. Okay, moving on. Now we have this. Now we need to see what else. If we have k equal to another value. So let's say, for instance, if we have k equal to 1, we could then plug it into this formula, which is here. This formula, you see this? So now we're just going to put k instead. We're going to put a 1 instead on that side. So if that should be the case, it's going to be written like this. -71.57 plus OK, or in this case, it's now going to be 1. One times our 180, right? You'll see eventually you're going to get the answer of this particular section as 108.43. Does this still suit our part? Yes, it does. So 108. If you want to change it up, and you're going to put the 1 inside of this formula. So instead of writing all of this out, let me just put the 1 here. Remember to want to save some time. If you put the 1 inside of that, you're actually going to get a value for x as 225. So that does not form part of it, because remember, it's only supposed to go up till 180. So the only values that we're going to have for our x's are x is equal to, you're writing it in its ascending order, so it's -71.57, 45, 108.43. You're more than welcome to try the others out, but I have tried it before. I do not want to waste your time. It's only like this that we have. You can try with 2, -2s, everything like that. That won't work. This is the only values where x is actually inside of the given question. Now, moving on to question 6. Question 6. You need to sketch the graphs of f of x, which is equal to 3 sine x times this over here. Now, I'm going to put differently. So let me write out how it should be. Gx is equal to tan. So g is actually equal to tan of x. Right? In the interval of, this is a, x is an element of -180 to 180. So my stuff didn't, I wasn't copied over properly, but this is what this section means over here. Calculate all intercepts with the axis, turning points and asymptotes or asymptotes. And that is worth 6 marks. So, okay, now for this particular section, we have this over here. Now, things that we can see here immediately when it comes to our f of x graph. Our f of x graph is 3. So remember the number in front now, so that means a spread, it's made wider, it's made higher, right? It's stretched. So we know for a sine graph, it usually starts by 1, -1. It usually starts at the bottom, it's the highest point, and it goes up to 1, and then it goes down and around, comes up like this, all right? And we normally have different values such as 90, 180, 270, and 360 over here. All right, and this goes the same the other way as well. That's how it usually looks. But because it's 3, this entire part was pushed up over there. This was going down. So now it's actually going to be by -3, and this is by 3. So everything will go up. And that's how f of x was changed. How was g of x changed? Well, erase this. So we know the usual graph is going to look like this. Yeah, g of x. So g of x is equal to tan of x. So because g of x, so because the half is over here, that means we change the frequency of how it looks, right? So this should be changed. So it's now going to be, we're going to have to try and calculate the period of this graph now. How long it will actually take to complete this entire graph. Now, usually with a tan graph, the tan graph usually looks like this. We have 90, 180. This is usually where you have your asymptotes at this point here. Now this is to complete the entire period, right? Like where it usually goes like this. And with that graph, it usually goes up like that. And with this part, it goes, don't touch and comes this way around. Yeah, and it goes further. Because remember here, you have 45. Here you have negative, just added 45, so it's 135 over there. And that's as the usual one looks. But now we have this half over here. How does it actually change that? You're going to say the period. It's not now going to be 180. It's going to be your 180, the usual amount, and you're going to divide it now by the coefficient before that x, which is half, which is 0.5. It's going to be equal to 360. So it's not going to just end here. The entire shape is now going to move. So this is 360. Now, the way this is going to work is that, unfortunately, I do not have a graph paper right now, so let me just show this to you. We're going to have it as a 1, 2, and a 3, and then a -1, a -2, -3. We will go with 45, 90, 135, 180. What you do on one side, go the other side, -45. You, of course, in your exams, going to be using a ruler. You will be having your asymptotes as well. Asymptotes on both sides, asymptotes on both sides. I would, of course, ask you in order to write this down, but I won't be able to right now. So we have this particular section over here. I see something about general solution. Okay, we'll try and show you that soon, but remember your general solution and a specific solution. That's going to be where we have this k is equal to your integers and things like that. So just go over that work, right? So you know that what you must study as well. We can continue with this quickly. Now, when it comes to the spot, we moved the asymptotes because of that tan is equal to, because this tan was equal to half of x. So instead of having it as 90 as our first asymptote, it moved now. All right, we moved it over. I know it was 360, but that's the entire graph that we have. So this entire part just moved to the entire thing over here. The entire thing was expanded. So because that is the case, we don't put the asymptote here now anymore. We don't put the asymptote here now anymore. So dealing with the first graph. When you have it as, now you're going to type that into your formula. Remember, this is now going to be in the given interval of in this, at least this here. Oh, I took the income slide. It's going to be into negative 180 to 180. So that's why we deal with from here. Remember, whatever they give you, you go from here to there. So, okay, now we are going to go and we're going to write down first our g of x is going to be this point over here. If you actually are going to type it in, tan of 90 will be equal to 1. So that means at 1 and 90, that's going to be where our value is. So it's going to go like this. It is here. And negative 1 will be over here. Our next part will be further down. So then you're going to move it up like that. Come on. Come on. It's going to go around. Going to go like that. And then all the way up. And don't touch exactly over there. But that red one is going to be your g of x. G of x. G of x is going to be your tan graph. Remember, I showed how it actually looks. It's actually tan of x. Change color to make it easier to follow along for the next one. So I told you how the graph normally looks, and now we're just increasing the height of it. So that means it's still going to start at 0 also. But in this case, at 90, it will be by 3 instead. So we're going to have it like this. Please guys, just go over your graphs. This will cause, it'll make it easier for you guys to understand as well. And just make it, you'll see it's worth a lot of marks. So it'll go up, and then it'll go down, and it goes there. This one, it will go till 3 by 9, 3 by 90, that's right, and it goes up that way. And that is going to be your f of x. There we go, f of x. Okay, and that's going to be where you get your 6 marks. You're of course going to then write where your turning points are. So then you'll write it at this point here, at this point here, which is 90 and negative 3. You're going to write where your asymptote is at negative 180 and 180. 6.2.1. Use a graph to answer the following questions. 4, and then it looks weird over there, but what that actually means is 4, bring back to red. That is going to be our x is an element of negative 180 to 180. So you need to write down the period of G. So now I'm going to look at the period of G. Oh, we've already calculated that. Remember, I showed you how we calculated it. So that is just going to be 360. There we go. The answer is just going to be 360 degrees. Right? That's why it's worth 1 mark. That's where you get to mark. 6.2.2. Write down the values of x for which the graph is undefined. The value of x for which the graph is undefined is going to be biased asymptotes. Where do you find the asymptotes? At negative 180 and 180. So therefore, you're going to say your answers is, the reason why I'll see there's so much blank size in between is just for calculations if I needed it. So therefore, you say x is equal to negative 180 degrees, or x is equal to 180 degrees. That's where you get your 2 marks, the positive and the negative value. Okay, now 6.2.3. write down the range of h if hx is equal to f of x minus 2. Yes. So now speaking of the range, now remember whenever it comes to a range, that means you're going to be speaking of your y values. So write down the range of h of x. Remember, we only had in this case f of x and g of x. This is now going to be a new thing that we have, but we're focusing on f of x. So we look, where's f of x? There's this one over here. Now, if we're speaking of the range, remember we're speaking of the y values, the 3 and the -3. Right, so that's its range. So when it comes to the range, you're going to write down the y is an element of, you put it like that, it's going to be, remember, as a range is -3 and 3. But what does this -2 means? It means that it's moving your range downwards in both cases. So in that case, you say it's going to minus that by 2 and minus this by 2. So this will be minus that by 2, minus that by 2. So your new one is going to be y is an element of -3 minus 2 is going to be -5. 3 minus 2 is going to be 1. And that's where you get to 2 marks. Another way you can write, because I know some people choose that way as well. As you can see, these are included brackets. Remember, because dealing with a range, it is hitting that points. You could also just write as -5 y -1. There we go. Both ways are correct. But you will get to 2 marks over there. And that's I get 6.2.3. One more for question 6. How many solutions exist for f of x is equal to g of x? That's worth 1 mark. All you do is you go to your graph, you go look, where does the graphs meet? At how many places does it meet? So where will it be equal to each other? We'll choose a different color that's not either of these. Well, I see they meet here 1, they meet here 2, and they meet here 3. So therefore, your answer is going to be how many solutions? 3 solutions. And that's going to be when you get your answer. 6.2.4. Okay. Moving on to question 7. And this is now going to be our still trigonometry. Yes, 5, 6, 7. So, okay. Here in the diagram below, PQ is a vertical pole having height h meters. So is this part over here. RQ and T are 3 points on the same horizontal plane. PR and PT are cables, and the angle of depression from P to T is 30 degrees. PR is equal to 3H, and angle PT, which is 2 times our angle R, is equal to 2X. Let me get to my question 7 as well. Yes, everything is written there correctly. Now, we move on. Write down the size of P2Q. Right, so that's going to be of P, T, PTQ, right? The size of PTQ. So where do you find PTQ? That's going to be this one over here. Because look, here is P, here is T, and here is Q. So of course, we're looking at that angle. Now, how do we get the size of this? As you can see, it's only worth 1 mark, so it should be very easy. Can you guys put the answer in the chat? Only 1 mark. Let's see if you guys know what this is. I'll take a sip of water slide. So here, this is what is very important at this question. Angle of depression. So I don't want you guys to feel depressed when you're writing maths, but when you're dealing with this, angle of depression, which is this line here, line P, as it goes down. That is the angle from P like this, right? That is in relation to the ground that we have over there. So that line and this line actually parallel to each other. So that P, which with that gradient over there, as it looks down like that, is equal to QT. Perfect, thank you. Thank you. Yes, you guys are giving the right answers. So because those are the exact same, all right? So that's why we are going to say now that that is going to be 30 as well. So angle PTQ is 30 degrees. And why? Because let's take all this erase of this the ink. So that shows that, click on slide, this is parallel to that. So when we have parallel, you know, there's three different things that can occur: alternating angles, co-interior angles, and one more. Yes, alternating angles, co-interior angles, and the functions, right? There's just quickly, yeah, and you have the three others. Co-functions, so you know, we have the one look like a F, the one look like a U, the other one look like a N. So in this case, we're going to use this line over here. It goes and it comes down and it goes here. So that 30 degrees is the same as this. So that is alternating angles. So alternating angles, corresponding angles, and co-interior angles. There we go. So this is alternating angles. So too much on the slide. So all we have to say is PTQ is equal to 30 degrees worth 1. There we go. 7.2. Determine the length of PT in terms of H. PT is over here. This one. PT in terms of H. Right? So the length of it. So now let's write down what we have. So okay, we'll move on. So there's a lot of triangles over here. So let's write down the triangle that we are going to focus on. Okay, so let's erase the ink of the slide. So that is going to be triangle. There's going to be triangle P, Q, R. As you can see, they said it is a 90-degree triangle, so we write it like that. We have our P on top, and we just calculated R. R was 30. Right? So we have it like this. Here you can think, okay, how are you going to get angle P? Because I mean, angle P is just going to be 90 minus 30, but we don't need that right now. We're not going to need it right now. We're going to focus on this sign that we need. We need the side of the angle, which is the hypotenuse. And how do we get there? Let's use angle 30. Do we know different sections? Yes. We know this is H, as given over here. Right? We know H, and we want to find out what the hypotenuse is. So what is PT? So we want to know what this is. So if that's the case, it's going to be opposite of a hypotenuse. So that's sine. So sine of 30 degrees is equal to your opposite, which is your hypotenuse, over your PT, like this. So now we are going to first try and make PT the subject of the formula. So that means it's going to be PT sine of 30 is equal to H, but we want PT on its own. So therefore, we just know it's going to be now H divided by sine of 30. So we go to the next side. So that is PT is equal to H divided by sine of 30 degrees. Now, 30 degrees, we can rewrite it as well, which is H divided by a half. Divided by a half, right? That still means the same thing, which is 0.5. Now, we want to get H on its own. So because we have a fraction, we're going to multiply it now by its inverse. So it's 2 over 1, which is still 2. We do the same over here, 2 over 1, which is still 2. So that means it's going to be PT is equal to 2H over nothing, because we got rid of it. And that's going to be our final answer. 2H. All right, so PT is equal to 2H. And that's how we've done 7.2. So, okay, now we move on to 7.3. Calculate the size of X if RT is equal to 7H. So, okay, I want you guys to give me the value of X right now, and the value of X, it will be in degrees, of course, because I want the size of X. So let's see now if you guys can give this answer with 5 marks. In the meantime, I'll write down for RT. So we know RT is going to be this bottom angle over here. Right? We know we have that over there. We know we have this side over here. And we just calculated values for PT now. Right? Where we said we have there's 2H. So I'll write it up. So it's going to be P is equal to your R. Sorry, not equal to, but it's just R, and this is T. And we have it like this. So what we know, 3H, calculated this, 2H, and this is going to be RT is 7H. But that was actually a bit of a mistake of how I wrote it down because I didn't copy over properly. So that's actually square root 7 over H. Sorry about that. So that is square root 7H. And that is what we have, right? So we have this over here. Now, what do we know over here? Well, we are given all of this, and we are given this. This is this part as well. That gave us 2x. Now, this is actually cool because we have two sides, and we have an angle that's in between those two sides, and then opposite that angle, which are unknown angle, is another side that we know. And if that is the case, we could also say we have two sides with the angle included. So the angle in between those two sides is known. And then the side opposite is what is known. So we will then be using the cosine rule. Right, so we're going to use the cosine rule. So now we're going to write all of this out, our P or T, in terms of the cosine rule. So here we go. So that is going to be RT squared is equal to our PT squared plus PR squared minus 2PT times PR times cos of angle P. Now we're going to substitute all of this with what we have over here, and this is how it's going to look. So we know that RT is actually square root 7H. Remember, we are squaring it right now because as part of the formula, and RT was given to us in that question. And PT is actually 2H squared plus our PR, which is 3H. Don't forget to square, minus our 2, what is PT? PT is just 2H times our PR, which is just 3H, multiplied by cos of an angle P. What was the angle P? 2x. Once again, it was given. So what is square root 7H squared? Well, that is just going to, if you have a square over here, you square both. So it's going to be 7H squared is equal to. So you do the same here by 2H squared. So that's actually going to be 4H squared plus 3 squared is 9. H squared is squared. Yes. Minus this part that we have over here. So come on. That is going to be, let's see this over here. Okay, multiply this together. Yes. Because this is multiplied, so that can be 2 multiplied by this and 2 multiplied by that. That's correct. So over here we have it as, no, sorry, those are like terms. So let me rather, there's no terms in between. Sorry about that. Don't multiply it like that. So these two are going to multiply each other. Right. So we're going to have this together. Yes, that's going to be H squared. All right. So what we could do is we have it like that and that. So let's put this together. So 4H, and that's just going to be the 6H, the 6, and that's times cos 2x. Okay, so I have it like this. Then we're going to put all of these together. This should be, oh yes, thank you. I see you guys put your other answers already there. That's correct. So, okay, now you put all of this together. So 3, 6, yes. So, okay, now that we have it all like this, there's a lot of H's that we have. So we are going to 12, so it's 3, 6. Yeah. Ah, yes, here we go. So that's how it's supposed to be. So yeah, you're going to say these two first multiplied by each other. So there's going to be 2 times 3. There's going to be 6. And then that 6 multiplied by that 2 is 12. So it's 12h squared. There we go. That looks better. Multiply by this. Now everything is in squared. Now we can actually make this, we can go further with it. So that means this is going to now be all of these together. What can we separate and what can't we separate? Well, this is one term. Do you see as minus? There's no plus or minus in between these. So this can go to one side, but now I'm going to try and make it positive. So I'm going to have it as 12h squared multiplied by our cos 2x is equal to, and then I'm going to swap the signs of the other ones right now. So at least know this will still be the same. So that will be 4h squared plus 9h squared. And then this is going to be coming over the equal to sign. So it's going to be minus 7h squared. Then we will just have it as cos 2x is equal to, if you're going to do this, 4 plus 9 minus 7 is going to give you an answer of 6h squared. And then you're going to divide it by this 12. The h's will cancel. And then your 6 can go into this. So that cos, come on, cos 2x is going to be equal to 6 divided by 12. That's still 1 over 2. Okay, but we are not done because now we need to get this on its own as well. So now we're going to say 2x is equal to our cos like this of a half, and that's going to be equal to 60. Yes, 60 degrees. But please do not end here because now you must say this 2 divided by 2, and that's 60 divided by 2. So therefore, let me write it on here so you guys can see it a bit better. Yeah, I had it as 2x is equal to our cos minus 1 and a half. I didn't have another slide to work on. So now we're going to get this on its own. So therefore, 2x is equal to 60 degrees. And then you get x on its own. So you divide by 2, divide by 2. Therefore, x is equal to 30 degrees. There we go. And that's your answer. Okay, that is 7.3. Now we're on to question 8, Euclidean geometry. Here we need to look at this diagram. There's quite a lot happening inside of it. I know we're going a bit over, but I'll just try and get through this anyway. Calculate with reasons the size of O1, right? So angle O1. So if we look at angle O1, where do we find it? It's this one over here. O1 is this angle here. Right? The other information is given to us there. So if we look at angle O1, what can we know about this? Well, in the diagram below, the circle having center O passes through UTS and V. So as soon as you center, you look at your center, which is this. Is it touching this end of the circle anyway? Yes, it's touching here and touching here, which means this or these are radii. They are equal to each other. So that's angle OT, or line OT is equal to angle OU. Whenever you see that. Here they also say it passes through UTS and V immediately, cyclic quad. You can see that's inside of our circle over here. Because the circle, the 4 points is inside of our circle. And then there they say we have PUK as tangent to the circle. As soon as you tangent, you must think tan chord theorem, tan radius theorem, right? And you see perpendicular things over here. As you see perpendicular, then you can think of your 3 different types of angles. Okay, so And now we move on to O1. So when it comes to O1, which is, like I said, is this angle over here, we know that, and then we have radii coming out between both of it. So we can write it like this. So we could say angle O1, or just put it like that, angle O1 is equal to, is there anything else that we know on this graph? Yes, they told us this is 75. This is 75 here. So that angle, or angle is made up by this point, and we move around to P. So that is what that angle is made up of, right? So angle S is made up of angle S and U. But that angle S and U also makes up this and this. And remember, that's to the center. So immediately that should show you as angle at center is 2 times the angle at the circumference. So that means we now can write it out like this. So our 2 times our angle TSU, which is this one over here. Right, so it's 2 times that section. So that's going to be 2 multiplied by 75 degrees. And that is going to be equal to 150 degrees. And reasoning, angle at center equal to 2 times angle at circumference. That's where you get those marks, 2 marks. So 150. So remember, angle O1 is 150. Thank you for answering as well. When it comes to angle 8.1.2 U5, so angle U5. Where do we find angle U5? Angle U5 is this one over here. This one over here, right? That is angle U5. Now it goes actually all the way over till the chord, yeah, it hits that. What do we know about this? Well, we have a tangent, and we can see that we have something else. Right, it goes all the way until our T. So it's on the outside that we have. So we can look at about it like this. As we have a tangent, but remember you get the tan radius theorem, and there's various ones for the tangent, but we also have tan chord theorem. Do we have a chord? Well, yes. This is going from one side of the circle to the other side of the circle, and it's hitting our tangent. So we have our tan chord theorem. And as we know, for the tan chord theorem, is equal to the angles opposite of that chord. So what is the angle opposite to our chord? Well, in this case, we see the angle, which our tan chord theorem, if you're not sure, remember this is tangent that only touches the place at the one place. This is the chord that we have over here. This is the angle. This angle is going to be equal to the angle opposites, which is going to be on the other side where it meets, which is bam. Luckily for us, it was already given, so 75. So therefore, you can say angle U5, which is this one over here, is equal to angle TSU, right? That angle. So therefore, we can say it's also equal to 75 degrees. Why? Because of, so dot, tan, let's put in this bracket, tan chord theorem. And that's where we get this part. Tan chord theorem, 75. There we go. Nice. Good job. Okay, so that is another 2 marks done. Wham. So see, we're just going to break it up nicely like this. Okay. Sorry. 8.1.3. T1. This one is worth 3 marks. T1. Where's T? Here is T. That is T1. Okay. So we have T1. Now, when it comes to T1, we know certain things that was on this diagram. As you can see, I need to keep moving on. So that's why I don't have everything on the slide right now, but we were given certain of these sections. We calculated that this is 150. Remember, it was double this angle. So that was 150. All right, that's a 150 over there. We know what this spot is over here as well. Now, what you can focus on is, remember, these are radii. These 2 bases are radii. where they're equal to each other, because it goes from the center to the edge of the circles on both sides. So what that means is we can now state that in this triangle now, where we make this line, and this line. Too much, don't look nice, but in triangle, let's make a TOU. Yeah, this is in that triangle. Remember, it doesn't matter what place you put it in, but TOU. In that triangle, we can say that 180 degrees minus 150 degrees. Why? Because we know it's this part here. Is going to be equal to, let's add that up. So, or let's minus those two from each other, 30. So it's going to be 30 degrees. So which means, reason why I'm getting this from is angles in a triangle, or sum of angles in a triangle. So we know that all three angles in a triangle should always equal to 180 degrees. We know that this one is 150, which means these two is what we need to calculate. Now we saw that if that is 150, both of those should equal to 30, but they only want angle T1. So because they only want angle T1, we can then divide it by 2. So there we say angle T1 is equal to 15 degrees. Because remember, this will now be 15 and this will be 15. Why? You have your equal radii. 15. Nice. Good job. So, okay, yes, there we go. Yes, you guys have that as well. Perfect. Okay, that was, we'll get our number 3 from. 8.1.4, angle V. So this big one over here. This big one here for that angle V. Now, how are we going to do angle V? There's a lot of different ways for us to do this one, but this is the one that I came up with. For this one, we already calculated certain things of these. What did we do in our previous one? Yeah, we had our angle 5, a U5. We done this one already, right? We know angle U5 was 75 degrees as well. Because remember, it was the opposite of this angle as well, right? So we know that was 75 degrees. Now, for this one, we know that this line here is perpendicular actually to this line here. So these two are perpendicular. So TS is perpendicular to PUK. And now because those are perpendicular to each other, we could use the different types. Like I said, like it could be alternating angles and these different ones over here. All right. And the coincidence and things. So what can we do? Can either of these be related to our V? Well, yes. So we're going to say this one, or at least we will get there now, because remember they say cyclic quad. So what you can do is, because these are perpendicular with each other, let's change it to a ink on the slide. This one. It goes like this. It's here, it goes up till there, and goes down like this. Now this angle is equal to this angle here. So angle, that is UTS. So angle U5 is equal to angle, remember that's a 5, not the S, angle UTS. So angle UTS is equal to 75 degrees. But that is not what they're asking from us. Remember, this is alt angles, right? Alternating angles. Alternating angles. Okay, but that's not exactly what they're asking from us. They're asking from us our angle V. And now you deal with your cyclic quad. Now remember, for a cyclic quad, the opposite angles in a cyclic quad should equal to 180 degrees. So because we now know what angle T is, we can say 180 minus 75 now will give us this V. So angle V is equal to 180 minus 75 degrees. And that will give you an answer of 105 degrees. And reasoning, I'm just going to write on the side over here. Opposite angles of cyclic quad. Trilateral, we'll write this. and that's angle B. That's where you get your 3 marks. So that's why it's important to know it was a cyclic quadrilateral. So know all your rules for each shape that you have. Moving on. 8.1.3, U3. U3 is this one over here. Angle U3. Angle U3, U3, U3. There's a lot happening again. So this is in a triangle as well. Angle in triangle GUS, right? That's in that triangle. But once again, there's different ways for us to get this. G. Okay, so let's think about it this way. I'm just saying there's a lot of different ways we can cover this. Okay, I think we're going about it this way. Angle, this is going from our diameter and is hitting our chord. So we can then say, sorry, yeah, diameter hitting our chord. So we could actually then say, when this happens, remember, this is now going to be, this entire part here will be 90 degrees. All right, because that is that over here. Was remember, this line is hitting a tangent. So we know it always hits it and gets it as perpendicular. Yesterday is perpendicular. Angles in semicircle. Okay. Yeah, that's one of the ways. Yeah, right. So that's correct. These different ways. Most of the answers that you guys were giving is 15, but it's true. These answers are 15. Okay. Now, so angle GT, which is on this side over here, we can say is this angle that we have over here, right? GT, with my marker. There. We have the spot over here. So that is angle G2. That's also going to be where a circle where it hits at that particular case. All right, nicely on that side. So, I'm going to go about it this way. Erase. Remember, I said this is parallel to this one. So that means this line goes parallel like that. And then we carry on this way. And then we move this way. Which means, because both these are parallel, we have co-interior angles. We just said that this is 90 degrees because this is heating from the diameter to the chord, so it's heating that, right, at 90 degrees. And when you have co-interior angles always add up to 180 degrees. So therefore you say angle G2 plus angle GUK. GUK is equal to 180 degrees. Why? Because of co-interior angles. That is equal to, always equal to 180. Yeah, just co-interior angles. Co-interior angles. Let's just put it like that. Dot, co-interior angles. So, okay, now, if that's the case, we know GUK is 90, right? Which is this now over here. It's 90 degrees. Right, so I have it like that. Now, in this spot, if you take just angle GUS, which is this section over here, right? Just the angle that you're dealing with. Take everything off. Just this angle to get to U3, right? This 3 here. Right, so we know G2 is 90. We know 75 is 75 given, and we'll just be left with the last one. So therefore, you can say angle G2 plus 75, which is this one over here, plus our angle U3, which we are looking for, is equal to 180. Why? Because of angles in triangle, right? That's your reasoning. Now we just make the subject of the formula. So U3 is equal to 180 minus 75 minus 90. Type all of that in your calculator, and you should get an answer of 15 degrees. So even though you guys just done with angles in, I see someone else done angles in a semicircle. So in other words, I have it over here. That's a 15. Sorry, it's been a long time. So 15 degrees. So you still get the same answer. Okay, that was angle 8.1.5. Moving on, 8.1.6, angle for G2 with 3 marks. All right. So what is happening over here? G2 is found here. Oh, hey, we already done G2, guys. We already have G2. But remember, it is 90 degrees. Without literally showing you why now, but another way, like we said, it is, we have it like this. Our we have our parallel lines, just like that. And then we can show how it is changed amongst each other. All right, so this angle here, say that's because of alternating angles. Because say G2 is, if you can make your Z like this, bam, 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 and that. And we know that is also 90. So that's why G2 is 90. So another way you can say it is because of ulterior angles. Right, so G2 is equal to 90 degrees. Okay. 8.2. If it is further given that TS is equal to 80. Let's just make sure that it's that. If it's given that TS is equal to square root of 80. Square root of 80, yeah. Calculate the length of TG with reasons and leave your answer in the simplest SURD form with 2 marks. So, okay, we should do that. Now, it is given that TS is this here, is equal to 80. So this entire part here, TS, which is this whole line, they say is equal to square root of 80. 80, that's a yes, 80. Is square root of 80, right? So what you could then say is, okay, if we take this apart, how are we going to get what is the length of TG, which is only this part here? So, yeah, this part here, TG, only this part. Well, we can then look at different color. Yeah. From the center, right? It hits that perfectly over there. All right. The diameter hits that perfectly, which means that's going to be hitting it in the point that way, right? So basically the line from the center, and the line from the center is perpendicular to the chord, because you see it's going from one side of the circle to the other side of the circle. And if that is the case, let's just get those people in the meeting as well. Okay. So, okay. So it's going to break that perfectly in half, because this line from center hits the chord perpendicular. So that's we'll break it into half. So let's write. That means our TG, which is this side, is going to be equal to TS. Oh, sorry, GS. Yeah, GS. Take that away, doesn't look nice. So that is going to be GS. There we go, GS, which is the side here. The values are equal to each other. Why? Because, like I said, line from center is perpendicular to the chord. So what is that going to be? So